Hello there, ladies, gentlemen, and unicorns. Welcome to my first Twitch-only stream. Well, that's not actually correct. I already streamed this week. And but this time it's my first stream that's only happening on Twitch and not on YouTube, as you've probably noticed when you're here. The reason for this is, as I've laid out in a short update on YouTube, is that somehow I managed to accidentally become affiliated with Twitch, and that means they have the exclusive right to all of my live streams for 24 hours. So this one will go up on YouTube after 24 hours. So that wherever you are watching this, thank you so much for watching, and I hope you manage to get it when you want it. Okay, Commander Stitch added me. I've added this. Hello, Commander Stitch. Again, welcome to another episode of me reading just too little of the chat and then being utterly confused about what's going on. So if you want my attention, please add me, because then I know I need to pay attention what's happening. And I also hope that my audio troubles that I had with my last stream are gone right now. The only thing that you can hear that's not supposed to be there are the blackbirds chirping outside, because summer is around the corner. Cursey Boo says audio is good, wonderful. The problem, as it turned out to be, was my powered USB hub, because when I was trying to get my Rocksmith streaming setup done, spoiler alert, it didn't work. Somehow I messed up something there, and now I had this current hum there of some kind of interference. Tried another USB port for the microphone. Things are pretty well now. Okay, so today, thank you so much for dropping by. After 4 weeks of streaming your beautiful games for Ludum Dare 46, I want to finish this off with streaming my game and then doing the whole code review of Game Maker language code. So where I just line out what went well, what didn't go as well as intended, and where I try to find my way around my own code after 1 month of not really looking at it. Sorcerer says, oh, my internet is struggling to keep up with the 1080p 60. Okay, so is it just you, or is it me that's streaming with too much bandwidth? Because, of course, I can switch back down if that's cool with you. I just thought that I will do 60 FPS for the game itself and then switch back to 30 FPS for the code review, because with 720p I don't think you can read the code as well. It's probably just me, Sorcerer says. So you know what? I will try now to switch my streaming settings there. Oh dear. Because I don't think it shouldn't be much the problem of the upload of my side. At least, yeah. I'm doing a video conversion in the other window, and I have to stop it when I'm streaming. So, Sorcerer says I'm only one viewer, so yeah, don't spoil it for the others. Yeah, but I mean, I just want to make sure that next time things are as smooth as possible for anyone, and with 1080p and 1080p and 60 FPS, I'm just showing off that I reign supreme when it comes to uploads here in the building where I'm at, because with the downloads, that's the whole problem there on a Sunday evening. Okay, I guess with that quality I should expect a massive fill on the wall. Maybe I've switched down the quality next time. So, you know what? Let's try this. I will stop the stream now. Bump the microphone shortly, and I will just bump it down to 30 FPS, but still 1080p. So I think this would be a good middle ground. Just let me know what you think, and I will finish my coffee in the meantime. I already finished it. I wanted to get a nice cup of coffee prepared, and now I was just trying out to get all the chat integration and everything there with Twitch, and yeah, turns out I completely had my coffee. Okay, so I will stop the stream now for the time being, switch it to 30 FPS, and then I should be back up again. And let's hope that everything else is also working there on the side of Twitch. Really, I'm assuming Twitch can handle this. So see you in a couple of seconds, I hope. And we should be back. So it's 30 FPS now, the peasant's frame rate, as I've been told. But I think it should be good. My game is not that fast paced that you can't follow it if it's just in 30p. Okay, so did anything change here with the light? I look a little bit too red. Maybe if I turn this one here. Oh no, it's it's probably because I'm running flux on my screens. Let me just disable this until sunrise. Then my screens should be a little bit more blue and things should look a bit more sci-fi. Okay, so let's get started. And apparently, oh look at this, I'm streaming again. Wonderful. Cool, still seems good. I hope sound is also good. So let's switch over to the screen then. And if everything works, there should still be the chat just below of my little portrait there. So yes, my game for Ludum Dare 46 was Rampage, and you will learn all about how this game came to be in my upcoming post-mortem. Still working on the script, but I'm hopeful that we're getting there before 131 days have ran out on me. So yeah, I'm pretty positive at this point. I always have to say at this point that I managed to get it done before the next Ludum Dare. So yeah, those are some screenshots there. And my game is only about Remy. The ram has injured himself and become hostile to anyone around him. As we all know, animals that are hurt are just dicks. You must lure him to the vet so he can get proper treatment without getting trampled on or trampled, and without Remy injuring himself even further in the process. So I think this is pretty straightforward. Features, the only feature is a tutorial, and the tutorial will also tell you how to play the game, and there's a whole playthrough if you're playing this on Mac or want to play this on Mac, but I don't have a Mac export from GameMaker. Yeah, credits is this was started in GameMaker. I went to Unity and started over there and didn't go as well, and then returned to GameMaker, and yeah, this will all be in the post-mortem. And we can download here the GameMaker 2 source project or the Windows version. And I'm extremely happy with my results. This was the first game of mine that was in the top 100 or top 500 in terms of fun, because let's face it, my games so far haven't been fun, and with this one I really tried to focus on gameplay first and then everything else, and look at that. I'm just humbled by how well this game performed. So thank you so much if you played it and rated it, even if it wasn't a full 5-star rating. As I always think, it's always better to be rated than just to fall through the cracks there. Okay, so let's have a look at Rampage. And please let me know if you can hear the music that should be starting right now. And I hope it's neither too loud nor too quiet. Okay, so this is my game. It's only vast. If you try it with cursor keys, it doesn't work. I'm sorry. And yeah, the walking is very slow, but this is intentional, so it probably feels a little bit too slow. And yes, I'm very happy with my little integration here of the tutorial, which is just text boxes. So sometimes you need to get out of harm's way. That's what dashing is for. To dash, move in any direction and hit space. I recall this. And after a dash, you need to catch your breath for a second before you can dash again, which is indicated by this. Let me try to zoom in. Can I zoom in? Apparently it doesn't work anymore. Underneath my little green health bar, there's this blue bar that's just filling up. And look at this. Down here, this is Remy the ram. Poor thing got hurt and needs your help to get to the vet. So this is probably a little bit annoying in terms of the audio of Remy. His injury makes him aggressive towards anyone, even you, and this is telegraphing the player already that, yeah, this guy here will break certain stones. If he hits an obstacle, he hurts himself even more. Yeah, and now I think the audio is piling up of this collision sound. You need to lure Remy to a safe zone in each map. This one also works, but it's probably hard to get him there. I will move a little bit further, hopefully that Remy will have stopped bumping his head, so we can hear this a little bit better. If you move too far away from Remy, he will lose track of you. And now we are here, and at this point people are probably a little bit annoyed by all those text boxes there. It feels like one of those very handholdy games, but yeah, this is what I came up with. So you can heal Remy with bandage packs, and at this point probably I would assume players would walk over the bandage packs and think, yeah, this, how can I pick them up? I can't do anything with it. I can just dash. And the game says they only work on rams, not cats, so be careful not to get hurt yourself. So I hope this explains what's going on. And if you watch closely on the upper left side there, it says this health pack icon ×0. When I interact with this sign here, it fills me up to 5, so that I can just start throwing bandages with hitting shift. And they're a little bit glitchy, but each time I touch this sign again, I'm at 5 bandage packs again, just to make sure that players don't throw one before encountering this sign and then they don't know what it means or what they should do with it. And of course, the last warning that Remy charges at you from outside of the screen. So here he is, and now this should finish the level. I mean, like I said, maybe I should have made some kind of achievement when you manage really to get Remy not to run into this safe zone, but the other that we saw from the tutorial before. So yeah, this was the first tutorial level, which is concluded now, the game tells us, and this was the very first level that I came up with. And you notice that the Remy has a little advantage over us, that he's faster as we are, and I think this was the intention of this level, to show you how you need to dash, and that he will be attracted only if you're in a certain radius around him, and so on and so forth. And this is the first real level where we are trying to steer him through what's going on here. And with this passage here, people have said me, Remy probably tries intentionally to hit all those stones there. No, he doesn't. And when I was testing this, well, actually I had my wife test it, and she lured Remy right through the gap at the first try, and I thought, okay, apparently it's possible, so you don't need to do this. As you've seen, I've slowed Remy's progress down, or his speed down, by just having him collide with one of those bandage packs. So this is a good way of having him slow down. And this is already the last level, and you can see here already starting in a bad position, so that you will probably die, or Remy rather will die before you manage to get there. Okay, so how to solve this thing here is to be very fast and either try to get Remy to this side or just on from the other side here, and then he will just have a few inches or pixels of life left. So this is why you should fill it up here, and then lure him here back. And yeah, this is pretty hard when you don't know the level layout, because now you can see the safe zone, but it's not as trivial to steer Remy there unless you're lucky, like I was right now. And that concludes the game. So you can see I more or less ran out of time and didn't come up with many levels, but I'm happy with how this turns out. And I even managed to have this little congratulations screen, because as we all know from the good old days, you feel very ripped off if after beating a game it just says congratulations in a little font there, and then it starts all over again, or it says, yeah, you should play this in 2-player mode, or you should have beaten this with a hard mode. Then of course there's the other side to this, and those are Kojima games where your payoff is a 25-minute long cutscene where you think, is there still game coming, or is this already the epilogue? So yeah, I just want to have a little bit of not surprise, but a reward in a sense for people finishing the game. Yeah, look at this, it's another artwork, and Remy loves us again. And we're back here, and now the zooming in did work. So this is already the Gamer Maker project, and at this point we're straight in the code review. Like I said, I haven't looked at the code in 4 weeks now. Let me just make this window big. So yeah, we will both struggle through my game jam code, but it's not that terrible. So first, as with all of my game maker things there, since it's room based, the first room is an initialization room, and what happens there is only one object. Where's my mouse pointer? I think I lost my mouse pointer. There it is. There's only one object, and the object is called control initialization. And just to open up here all what I have here my sprites, of course, then the title card and the ending card, so this is not very interesting. The UI is just this health pack. Then player sprites, environment sprites. Some sprites of the player aren't used anymore because I changed how directions are treated, so the player is always facing. But look at this, I had sprites drawn for even the backside of the player. Then we got environment sprites for the RAM, item sprites, which also is just this health pack there, helper sprites, which we'll encounter when we are looking at the individual levels, for collider, a certain zone, and a goal zone. So the only zones that I have is here the goal zone. Obstacles, also not that much, it's just the stone block and the debris. And visual effects, which are those little dust plumes, and yeah, it's called a plume, not a bloom, right? Dust plumes, and the shadow sprite, and a fragment when Remy is hitting the stones and they just give off those little particles. It's not really a particle system, as you will see. My implementation is quite wasteful, but very, very simple. Yeah, and I just only have one tile set and a couple of sounds, as you've probably heard, and some music there. And finally, of course, I have one script that is this debris hit, which we'll also see. And as for fonts, 4 fonts, big, huge, medium, and small. Nothing interesting there, because the interesting part, as always, happens within the little objects that I have here. And as you can see, there are a couple of objects. Some are parented to other ones, which is not very obvious in this one, but this is what we're here and we will look at. So the game starts here in the init room, and it runs this control init object. Let me find it again. And this init object has only one creation, only one code that happens on its creation. And this is just, yeah, setting the constants and global values for the game. So if the release build is false, let me just switch it over there. We will get, when I run this game now, which I will try now, we will get a couple of debugging information on the screen there. And this is why I said this here. I could have also done it via a macro or macro. What? Macro? I say macro usually. So a compute genius program says, "Hey, love your vids, can't believe I never knew about your Twitch." You're not to blame. I do Twitch for I think 1 month now. So you're still here with the cool crowd, with the cool kids who already knew me when I was still underground. So yeah, apparently I didn't run the game here. Let me zoom out and see what's going on. Oh, I was hitting Shift F5 for some obscure reason. So yeah, the game is now building. So this is good. So this is when the release build flag is turned off. And you can see here, it starts at a different level. I can see here actual radius of Remy there. And apparently, yeah, I deactivated some other debugging information, such as coordinates and so on. But this is, yeah, when the release build is turned off. Then, of course, because I like colors, and this with the color scheme here, I just made a certain constants here for certain colors that I could be sure that I always have the right colors when I'm using or referencing them. So yeah, when I just say color dark blue, it's always this color here. So this is why I make sure that, yeah, it's always the same color there. Also, the question in the chat is, when is the postmortem coming out? As always, when it's done. Still working on the script, but I'm working on it. Okay, then we have two more instances that I create, which are the input instance and the game instance. Those are two objects. They're just singletons, as you can see here, control input and control game, which are created until we go to the next room. So let's have a look at input and game before heading over to the next room. And control input and control game, as you can see also here, the first thing about those is they are persistent, so that they carry over when the room is changed, in stark contrast to the control initialization, which is not persistent. And when we go to the next room, so after this one here is done, so is the initialization object. So the input, well, pretty straightforward. What it does is taking care of all the input, and the game is taking care of all the game logic here. Okay, so those objects get instantiated or get created, and their references to them are stored in a global variable that is input and global game. So we can, at this point, when we transition over to the first room, which is room title. Now what could this be? Yeah, this one here is just the title screen. And then the next rooms are tutorial, game 1, game 2, game 3, and game end. And we will look at those rooms in a bit. So, input control. For some reason, I always reinvent the wheel, and most of the times I start with a new input control, and also this one here. So this is very bare bones, and yeah, to be fair, not very thought through, but it works for this game. So if I want to keep working on it, which I think I will actually, because many people said, yeah, the game feels a little bit too short, which I interpret as it was fun enough for them to play another level or two. So this is why I decided to keep working on this game as a little side pet project. So first thing in here in the create event, which only runs once, this is I think akin to C# functions in Unity, which is just on awake or on startup. So here on create, I just set a couple of variables here. So key up, key left, key down, key right, just to let the program know, yeah, those I'm referring to the keyboard codes here, and space, shift, and space again. Okay. And the key for next is the E key. I don't know why I'm using this. Oh, right, I recall it when I was doing the tutorial implementation. As you've seen before, now it's just when you're colliding with one of those signposts, it makes this little text box there. Before I had you interact with the signpost, and then it would have a text box that you can advance and to the next page. But I realized that this was more cumbersome to integrate, especially when you're running short on time. So yeah, this is still a leftover from this time. And I got a key quit, and now actually it should be structured like this here, because the following things are just flags. So when I'm checking in my game if the player is moving left, or the button for moving left is down, is held, then I just check if in this reference here in the object that's referenced through global input, is left. If it's true, then the player is holding down the left key, whatever the left key may be. Like I said, I'm just decoupling here the actual keyboard codes from what's in the input, what's going on. So if is left, it means the player is moving left, but which actual key it is, well, it's up to what's set here in the input control. So that, yeah, I have just this layer of abstraction there that I don't, when I want to change the controls later on, that I don't need to go through my code step by step and change the for example, the A key each time to, like I said, cursor key. The upside to this is I could also have mapping for players, that they map their controls or multiple keys for one certain command, and so on and so forth. So is health is true. I don't know why I have it here, but apparently there must be some reason. So on step, this is what happens on each step now here in the control. You can see here when debug. So when I'm checking the F1 key, so I didn't bother to abstract it out here. This one here is just hard-coded. When I'm hitting the F1 key, I can switch off the RAM. And if I hit F2, I can switch him back to attacking. So this is, let me just see here, if I hit F1, right now he's even stuck here in his animation. So just for testing purposes that I could switch on the RAM in and out. And you can also see here, when I zoom in a bit more, those numbers here, I think those are the health points of those individual objects there. And if I hit F2, I can switch the RAM back to attacking mode, and so on and so forth. Then if keyboard check pressed is space, so this means if I press space, then is space is true, otherwise is space is false. Yeah, I'm quite aware that my abstractions for decoupling commands here from the keys isn't quite waterproof or bulletproof, because like I said, this should be agnostic of the actual keys, and now but this variable is called key space. So yeah, I'm aware of this. And the same thing is happening here. If key for the next is pressed, then is next true, otherwise it's false. If key quit is pressed, this also shouldn't actually be happening in the input control, that the input control decides or has the authority to end the game. But I thought it's game jam code, so yeah, if you hit quit, or in this case, it is the escape key, then we end the game and also exit this function here, just to be tidy, I guess. And if here now for the movement keys, if we're hitting up, well then, or down, then up must be false. Or if we are hitting down, well then up must be false. So just that you can't go left and right at the same time. And this is just only once, because there's a differentiation, because you can see here keyboard check constantly checks a key if I'm holding a key down. This is true. And keyboard check pressed means only the first time I'm pressing a key down it is true, otherwise it's just false. So this is for things that are happening only once. I'm using keyboard check pressed, and otherwise I'm using keyboard check. Same thing here, when I'm releasing the escape key, then the game ends. So because sometimes I'm just hitting the escape key and it's, oh damn it, I just wanted to try this out, so I'm just holding down the escape key until I'm ready to exit the game. And also this next here is only pressed once, and space is only pressed once. Those are helper functions from Game Maker Studio in terms of the input, just that I don't have to do this programmatically. You know what? A unicorn, when I say unicorn, we all have a sip of water to stay hydrated, because I have a frog in my throat, as we say. Much better. Okay, so now we are here in the game control. And this is another persistent object that just manages the game state across all the levels and so on, that we know where we are. Okay, so the game state here is an enumeration. So I never compare strings. I've learned this the hard way, because sometimes you make a typo or do something wrong with the casing and half of your program doesn't work. So for my game state, I have an enumeration. And you can see here, some always have this appendix of _1s. This is my simple way when you're having a state machine. I want this to run only once, and then when the game ends, keep looping in the other state. For example, when I'm starting the game now, I switch over to in-game once. This sets all the variables and do some setups, but it only runs once, because at the end of this in-game once, it switches over to the next state should be in-game, and this is where it loops this state in-game until until in this loop the state gets switched to another one, for example, title once, or waiting for next level, and so on. So of course, now here we start with the state is of course init, and now here we have a levels queue. Usually in Game Maker, the levels go, you can say room next, and then it just hops to the next room that's here in the list. Yeah, sometimes, especially for debugging purposes, I move those around, that I start right at the room there I want to work in, and so on and so forth. And this is why I make usually my own queue when I'm doing level progression. So the level progression is not go to the next room, it's not happening here. But instead, I just create a queue, a data structure of a queue. And in this queue, I set the room names. It says here array, well, it's not an array anymore, of room and number. Oh no, it is an array of room and number of health packs the player starts out with. So this is the first thing that's maybe a little bit, well, not dodgy, but a little bit complicated when you first look at this. I'm enqueuing here each time an array made up of 2 entries. The first entry is the room name, as it is here, which is also just a constant, so that GameMaker knows when I'm switching to room 4 or RM_game1 is just an integer number. But the other number, like here the comment says, are the number of health packs the player starts out with, because I wanted to change those around for balancing purposes, and this is why I'm using an array here. So when a new level gets queued up, it just takes this array here and picks it apart in the part of, yeah, this is the number of the room I should go into, and this is the number of health packs to give the player. But we will see there. As you can see here, this is, like I said, for debugging purposes. So when this is the release build, it starts at the tutorial level, then at game 2, which was the first level that I was working on, game 1 and game 3, those are just level numbers with the corresponding number of health packs. Or when we're here and not in the release build, I'm starting in room 3, in the last room that I was debugging, so that I don't have to go through the other rooms when I just want to test this room here. Then we're setting some variables here. Room title is the room name of, or in this case again, it's the room number of the title room, the ending room, and so on, just that I don't have to manually type out room title each time. It's not so much the typing that's problematic, but when I change the name of the room, for example, I only have the reference here and it's bound to this variable, so I'm always on the safe side when I'm using those. Then, of course, the game needs to know about the player object or the instance, or a reference to the player object and a reference to the RAM object. Those are set here with the keyword no one, which translates to -1, so that GameMaker knows they haven't been instantiated, so that I can run just if checks on those. Player starting packs is 0. I'm assuming those are my, the health packs we're starting with. And then do UI is true, do overlay is false. The overlay text, the overlay is just at the ending of a screen of a level where it says, yeah, congratulations, hit space to go to the next, or you lost, or game over. So this is the UI and the overlay. The UI, by the way, is, I think we will get to this in a bit. The UI is just this little overlay there on the upper left corner, where it just shows how many bandage packs you have. And the overlay text, like I said, it is at the ending this text box that says level finished. And do check win conditions is set to true. Of course, we want to at each step want to just check if the player has won the game or finished all the levels, or the level they are in right now. Okay, do cooldown is true. What is a cooldown? It's related to this overlay text here that says, I'm quite happy that I've spent some time doing documentation, and the cooldown is to have a second before the game accepts new input, especially when you finish a level. Sometimes this happens when you're just frantically clicking and tapping on the keyboard, and somehow you finally manage a level, and you want a second to breathe, but you hit the button for, yeah, let's start the next level, and you're thrown in there right away. And this is why I have here, I'm just saying the cooldown in it is the room speed in ticks. It's always good practice to use delta time and not, in my case, ticks. The game is running at 60 steps or ticks. In this case, in GameMaker, it's called steps. So in 60 steps per second. So the room speed is 60, and when I'm counting down, as we will see in the cooldown, I'm just subtracting or decrementing it by 1, and when it's hit 0, then the cooldown is over. So this is what happens here with the cooldown. I just don't allow for 1 second after you beat a level, I don't allow any input to go to the next level, just to make sure that players don't accidentally trigger the next level. We start here with the cooldown. Apparently didn't quite, it's variable cooldown only referenced once, so yeah, we can actually take this out here because I didn't use it anyway. And cooldown in progress, apparently I used this one. So text continue, just to have the string here written once. That should I want to change it, I change this variable here. So hit space to continue. And the restart cooldown is room speed 1/10. So apparently the cooldown I set from 1 second, because it felt like when you were done with the level and you just hit a button and it wouldn't start the next level. I immediately here changed it, as we will see, to 1/10 of a second. So it's just, I think it should be 6 frames or 6 steps after level. That's the grace period where you just can hit anything without going to the next level. Yeah, this was just through iteration, back and forth. Yeah, how long is it okay that you don't immediately go to next level when you don't want to, but at the same time, how long feels too long, as if the game wasn't responsible or was just eating your key commands without doing anything. And music current is no one. Yeah, music was the last thing I implemented. No, it was sound effects actually. So this is what happens here when we create the game. So the next thing that happens here is the step event and the draw GUI. So here we can see here when do GUI is true and when do overlay is true, and nothing else happens here. So I will come back to this when we are in the game and we say do GUI, do UI, not GUI, do UI is true. So this was the create step. Now we go to the step. So this is what happens each time. Since this is persistent, this happens at each tick always. So if is it a release build and the layer exists colliders, we set the layer colliders to false. And now we have to look at the actual levels, how they look like in GameMaker. I just start here with the very first room. This is the first one I designed. This is not very interesting, but you've seen it. It was just this yeah, very, very short game here. And you can see those ugly pink stretched out boxes, and those are the colliders. So everything else here, apart from, well, the player and this signage here, but the trees and all the tiles, they are just background, because the player and also the ramp, for that matter, is colliding with, of course, the colliders. So whenever I place those kind of ugly pink boxes here, those are the actual colliders. Everything else is just scenery, right? And this green G here, this is a zone. In my case, this here is the goal zone. So it's not covering up entirely this circle here of the goal zone. But yeah, when I'm checking here, if my instance of Remy is colliding with the goal zone, well, then we've managed to get the level done. And as it is with GameMaker here, the rooms are made up of different layers. So let me just try to switch it over there. How does this work? Like so. Cool. Okay, so I can switch off the colliders, and this is exactly what happens in this initialization. Now this was the room here in the code here. That when the layer colliders exists in the release build, it should always be invisible, because of course you don't want those kind of pink boxes accidentally show up. And this was the first thing I think I coded, just to make sure that when I'm pressed for time, that I don't forget, or even should I forget to deactivate this layer, that it won't show up in the final build. Instances are all the instances that are placed. You can see also the trees and shrubs are instances and not really, like I said, just parts of scenery or parts of the tile map itself. We will get to why this is in a bit. And of course, the actual tiles here, if I switch off everything but the tiles, you can see the tiles. The tile set is made up, yeah, is very simple. And those are just tiles that are sitting there on the background, and the background itself it's just this repeating green pattern there. Let me switch off the grid display. It's just this green pattern here with a couple of dots strewn in. Everything else sits just on top. As you can see here, the tile map is just with lots of transparencies sitting on top of the background. Instances are placed and colliders, and this is how each room is set up. This was a simple one. Let's have a look at the very last room in the game. That with the colliders looks like this. I have here some colliders already pre-rotated here, but if I untangle it here, the background. Let me switch off the grid here. We have the background, we have the tiles, which are, like I said, just decorations and don't do anything by themselves. The assets, also some little pebbles of rock that are there. The instances of things that you can actually interact with. Because here with the assets, yeah, it's a three-part not three-part process. There are 3 different modes, or actually 4 different kinds of images you can have in GameMaker in terms of the background. For one is here the background image, which just is a repeating image, like I said, just for the background. The tiles you can only place, of course, on the tile grid. And how big this grid is, you decide, of course, with your tile set. And just to let you know how it looks like, this is what the tile set, I think it's a little bit wider, not much. This is what the tile set of the game looks like. There is really not much to it. It's just a couple of arrows here and this half circle of cliffside and a pit which wasn't used, and the stone blocks, and also stone blocks that set in the ground. But this is my entire tile set. But like I said, if you want to place something, for example, between 2 tiles, you can't do it on the tile set. But then comes in this assets layer here. And this assets layer, which is where the trees are. Where's my mouse pointer? I don't see it now. Here it is. With the trees and those little pebbles there. Those are just sprites that are placed on the background. They are always on their layer that they are. For example, if they are on top of the instances layer with the player character, of course, they render on top of it. But you can't interact with it or even check if you're colliding with a certain sprite or anything. Like I said, just decorative. And the instances are anything that you can really interact with and get their instance ID and do some checks. And this is, like I said, when we get to it with the shrubs and the trees, the reason why they are instances is that you can walk behind them depending on where on the screen you are. And finally, we have colliders, which are on their own layer, which is not visible, but they are there. Gee, I hope this makes sense and it wasn't too confusing, but this is how things in GameMaker are set up. And there's, like I said, you can reference layers by their layer name, which is a string. So this is why you have to be always very stringent with your layer names, that they are always the same, because if you change here the collider's name, for example, to something else, your code will throw some syntax errors, because what it was assumed to be the name of a layer just doesn't exist anymore. So you really have to make sure that you don't do any typos. Yeah, like I said, I'm not a fan of string comparisons exactly for those reasons, but yeah, that's just how it is. So if it is a release build, we just make sure to disable the viewing of the colliders. Thanks for laughing, Commander Stitch. So apparently there are still people here. This is wonderful. Thank you so much. So, and now we're checking if the current room, the green, by the way, those green highlighted words here are built-in keywords. And the room is currently the name or the number here of the room name. Like I said, those room names are actually just numbers. So if the room we are in is equal to the room of title screen, which means we are in the title screen. And if the game state is not waiting for next level, then we say, well, the game state should be title once. Like I said, then we are further down below here already in the state machine, where we just switch on the state and do certain things depending on where we are. So at this point, we are up in the title screen when we're switching the state, and the state is title screen once. So we don't do the UI. Like I said, it's just the display in the top of the screen of the bandage packages we have. We don't check for win conditions. We're on the title screen. There's nothing to win and nothing to lose here. But we switch the state to waiting for next level. And there also we have the states for ending once and ending, but we will get to this when we're there. Same thing goes for in-game once and in-game and RAM dead once. Of course, there's a different state when the RAM is dead or when the player is dead. but they all lead to that we've failed. And level 1, same thing. And waiting for next level, there we are. So if there is no cooldown in progress, that's another nested if statement. So if there's no cooldown in progress, then we check on the input if is space. As we've seen before, it's just checking true or false, or just checking the flag there in this reference if it's true or false. So if we're hitting the space key, then we can advance to the next level. So the next thing we check if our level queue is not empty, because if it is, well, we must be done. If we've beaten all the levels that were set up here in the create event in this level queue here, then the game is over essentially, and we have won, and we switch the state to ending once and go to the room that's called room end, which also is just displaying this one sprite as a background image. But if not, if we are on the title screen or pretty much anywhere else, we just say waiting for next level. If space is pressed, we switch the state to in-game once. So the next time this state machine runs, we will be in a different state. Then I'm just making a temporary variable there, and we just dequeuing what's here in the levels queue. And like I said, the levels queue itself is I queue up little arrays of the room number and how many health packs the player should start with. And this is what happens here. I'm just picking apart this array here. So the first entry is the level to go to, and the packs is in the number of the starting packs we have. So I'm just setting here the variable here to starting packs is packs, and let's go to the level that we've gotten from this array here. And the next time we are in this switch statement, we will be in-game once. So, and also if we check the win condition, this happens outside of the state machine for some reason. So if we want to check the win conditions, this is by looking at both the RAM and the player. So if the instance of RAM exists, always make sure that the references don't lead to null pointers anywhere. So I just make sure that the RAM exists, and if the RAM is safe, so when the RAM collides with the safe zone, as we've seen before, that was this green G, just to reiterate here that you can follow, if the RAM collides with this thing here, then internally inside the RAM instance it sets is safe to true. So we're just checking each frame if this flag actually is true, because, well, if it is true, well, then we have won the level. And if the RAM is not alive for some reason, which is also as soon as Remy's HP run to 0, of course we sets it's alive to false. So, well, if the RAM is not alive, then we switch the state to RAM dead once. And next we look at the player, and if the player is not alive, well, you probably also have failed the level, and there is a different state, player dead once. Why don't I treat the RAM dead once and the player dead once the same thing? For this I just scroll up a little bit here in my state machine. Yeah, if the RAM is dead, it says you didn't keep it alive, and if the player is dead, it says you didn't make it. And the next thing here is just overlay text 2 is just another line there in the text that says, yeah, hit space to continue. Same happens when the player is dead. Do overlay is true. We want to display the overlay, and do cooldown. We want this cooldown that we can't immediately just in the next frame skip to the next level. Same thing happens here with player. Do check win conditions is false because we've lost, so there is no need to check again for the win conditions. We don't show the player's health bar anymore because they are not important. Same thing happens here. And we stop the current music, stop any current sound effects that are playing, and cue a different kind of, or set a new music track that we play that is music fail at a importance or priority of 5, and false means it doesn't loop. So audio play sound takes 3 arguments. And we set its gain to 0.8, so it's 80% volume, and the next state is game state failed. So you can see the only difference here is this one line of text. You didn't keep it alive, and it didn't. You didn't make it, and you didn't keep it alive. Pretty much anything else I could have stuck somewhere different, because as Grace Hopper once said, she learned that two things that programmers can't do is they can't copy code from other projects, and they don't they are unable to write the same code twice for different things. Yeah, it was a different time back then when she was working, I think, on the ENIAC, World War II computers. Anyway, but for game jam code, I think it's okay if you just copy code over. That's doing pretty much the same thing, because actually it's better that way, because you don't know when you need to make changes to certain things that just only are apparently the same thing at the first glance. For example, if you have an enemy and different kinds of enemies, and you only change, for example, the color of the enemies there and have everything in the same function then. But then you realize, I want the other enemy to be a little bit slower. For example, the blue enemy just slower than the red enemy. And then you add a certain case in your function, and then you realize, but I also want a yellow enemy to be faster. And the blue enemy has a different attack pattern. And then you have this one function which has different or special conditions pretty much for every individual enemy there, and you would have been much faster, and it would have been much more legible to have each enemy separately in their own functions and just keep working on those, even though at the outset they looked very much the same. And this is why I just copied it over, because maybe I wasn't sure if I wanted to do things differently depending on the player's death or the RAM's death. But in the end, it's just this one line here that changes, and it switches over to the next state that is failed. And this is the same thing, like I said. Thank you very much. If you failed because you've died or because of Remy died, we're just checking here if there is a cooldown in progress. And if it's not in progress and the player has hit space, then we switch over to in-game once. So we're saying we're in-game, of course, and we restart the room, which is the last level of the level that we have essentially failed. So where is this cooldown in progress actually happening? It's here under this check of the win conditions. This also happens each frame independent of the state machine, so no matter in which state we are, because I thought maybe I need to use a cooldown in different places. So if do cooldown, well, of course, we do a cooldown. So when it's the first time the cooldown is run, so cooldown in progress is false at this point when we say do cooldown. This is also a nomenclature that I developed for myself. So when I prefix something with do, then it says to do something to start a process in a sense. This is a do cooldown, and then it says cooldown in progress. So this is why I have two different variables for this. So when I say do cooldown, then the cooldown is not in progress, which means we can initialize it. So the cooldown is the initial cooldown. Let me just flip over here to create event. And the cooldown starts here. What was it? Cooldown init and cooldown equals cooldown init. So cooldown, where do I have it? Don't have the cooldown variable here. This is weird. Do cooldown is true. So it starts out even on the title screen with doing the cooldown. The cooldown init is the room speed. I also start here with cooldown in progress false. So the cooldown init gets here set again to the room speed, apparently twice. And now the cooldown is in progress again. So this part here only runs once. So if we're doing the cooldown, I'm just decrementing the cooldown and checking if it has fallen below 0 or is equal to 0. Because if that is the case, like I said, after 60 ticks of running this, it just gets -1, -1, -1. And when it hits 0, or for some reason should hit a negative value, well, the cooldown is not in progress anymore, and we are not doing a cooldown. And this is everything that's happening here in this cooldown. So let me scroll up again here. to see what happens when we are in a game. That is, in-game once is being, the state is in-game once here. So when we are in-game, we switch off the overlay. So if you have had before the overlay of you managed to finish the level, congratulations, or you didn't make it, or you died, yeah, we're just hiding the overlay. And we also say we're doing the UI that is displaying the player's number of health packs, bandage packs they have. And the state now, once we just, like I said, we just do this once and then we switch to the next state where it gets looped over. So first thing we do is we stop all the sounds that might or might not be playing at this moment. Set the current music to the in-game music, so each time you start a level, it starts also the music anew. True, it means it loops, and 1 is the priority, but in this case, the value, the higher the priority value is, the more likely this is to stick. But since I'm not piling on that many sounds, I think a priority value of 1 should suffice. And then we play the current music. Like I said here, music current is set to this. Whatever this returns is just an index to the current music. And then I just set its volume to 60%, that it's not too loud, because you can't have blaring all the sound effects at the same intensity. Again, if you want to change to have an options menu for players that they can use it, just set their own values there. I would do just a global lookup to the value that the players set for global music value and just pull it from there. Okay, so in-game once is player equals to no one. If you remember when we created here the game, we said player is no one and RAM is no one. And at this point we are already not anymore in the title screen, but already in a room here, or like the tutorial or game 1. And what's very important here is that the player object and the RAM object need to exist in this room here when I set it up. Some here in the instance layer here, for example. I think, let me just check, it should be here. Yeah, in the instance layer. So if it's very important, because if no player and no RAM exists, because you've forgotten it to put it in the level design, then the game will crash with an error, because it needs those. So if the player is still set to no one, we need to find the player instance. And this is just what this function here does. It gets 0, it gets the very first instance of player it finds, and also the RAM, just that we have a reference to the actual game objects there. And Phantomeniazil, I'm really sorry. It's just so small there on my screen. So hi, thank you for dropping by. Right. And so we're just getting references to the player and to the RAM. And we also need to set the health packs the player has initially, which is the starting packs. And if you recall before, we get this starting packs value when we are loading a new level. Let me scroll down here quite a bit. This is what we get here from the levels queue from this array we just picked apart, is player starting packs equals packs. And now I scroll up again, so that we're just transferring the value that we have stored in the control game object over to the player object, so that they have the starting packs at the right number. And the health packs equals the starting packs, because sometimes, of course, you have an initial value and the current value, because if you use 1, then it's only, for example, you start with 5, then you use 1, it's only 4, then you restart the level, you want to have the player has 5 again. So this is why always I have an initial variable for something, and I also have a max value for something, but with health packs I don't think I have. Okay, so this was in-game once, and at this point we have already switched over to in-game. And when we are in-game, you can see here there's not a lot that happens here with the game control. All we do is we don't do the overlay, that is, congratulations, you finished the level, or you died. So this is always turned out or turned off. But we do check at each step the win conditions, of course, because the game is running. And this is what's happening here in the game control. So everything else gets done by the player and the RAM themselves. So I'm just making sure that I didn't forget anything. Yeah, of course, when we've managed to win the level, then the overlay text, you kept it alive. It also says hit space to continue. We don't do the overlay of the player's bandage packs in the upper corner. We do the cooldown. We don't check the win conditions anymore. And this is very important because sometimes with games when it's a very tough call or a close call, you finish a level, but then still an enemy hits you and the game is not quite sure what's happening because it's already saying, yeah, you've won the level, but then the enemy hits you and then it says you lost the level. This is why at this point, as soon as you say the level was won, I don't allow any more injuries to the RAM, just to make sure that nothing fishy is going on there. The state, the player has a state machine, the RAM has a state machine as much as here the game has a state machine. So we switch over the state of the RAM to waiting once. So this is just when it's idle. And the health bar, we don't need the health bar to show anymore. This is just clutter. So I switch off the display of the health bar for the RAM. For the player, pretty much the same thing. The player, I don't allow the player to get injured as soon as the level was won. And I also don't allow any more input of the player because, yeah, just all they are expected to do is to hit space. And I think some of us always have this, that we forget to don't allow the input. And when a player died and you display the death animation or the corpse sprite, and then but you forget to deactivate the input and then you can still move your corpse around. I think everyone has had this at least once in their game dev. Also, we don't show the health bar of the player anymore, and the player state is won once. Why do I need to change the state of the player? Yeah, it's just that it's going to display a different sprite. And this is also why the player itself has to know that currently the state of the game is won. Then I stop any current music playing, that is just the loop of the level, and switch over to music win, because of course we won the level, and set the music gain to 0.8. If you recall before, when we were in the level, I set the music to, where do we have it, in game once, I set the music to 0.6 to 60% volume, and when we won I turn up the music a little bit and set it to 0.8. Also when we've lost the level, just, yeah, as a little extra cue that you can really hear it, that it's something different than just the background music. And when we've won a level, we switch over to waiting for next level, which we've already seen, which just makes sure that when the cooldown is not happening anymore, we're waiting for a space and then just pluck the next level from the queue of levels. And if there isn't any left there on the queue, well, we must have beaten the game and we go to the ending room. And when we hit in the ending room space, the game exits. So this is pretty much it for the game control. Like I said, the rest is just the interplay of players and of the player with the different objects, such as the RAM, the colliders, the health, and so on and so forth. Yeah, then I got those little effects here that says effects plume and effects fragment. We will get to those in a bit, but those are just, yeah, like I said, I didn't use particle systems because it took longer to set up particle systems. I mean, they are better optimized for memory if you have a lot of objects that you want to keep track of. And I just create game objects, which of course have their pretty, relatively speaking, big memory footprint, so you don't want to spawn thousands of them each frame, but I'm not using that many, so it's okay. Okay, so I think the first interesting object to look at is, of course, the player object. Let me zoom out here. Did I double click it? Yes, it's all the way over there. So the player, as you can see, has a sprite, and importantly, it is not persistent between levels, so that each time we go to a new level, there's already an object, an instance, sitting there at the right position. Okay, so when we create the player and create some variables, what is happening here? First, of course, the player has a state. And also here, it has idle once, idle, active, dead, and won. So very self-explanatory. And the first state we start with is idle once, and the sprite is sprite player front walk. Yes, I have sprites for walking, front walking. That is just this one here. Yeah, not that interesting. Then when we are being hit, it looks like this. And when the player is idle, they're just standing around. And happy, and this is the sprite when you have beaten a level, then it just switches over the sprite to happy. Also have those from the backside, as I mentioned. So this is the walking sprite from the back, but I don't have a happy sprite from the back because you can't see the expression on the face of the cat. So even if we were turning our backs to the camera, as soon as we've won a level, the cat would just turn around, or at least it wouldn't actually turn around, it would just display the sprite of the happy cat. And of course, when we're dead, the same thing as with happy, you always want to see what's happening here. And we got this little X's for eyes, and the cat is now just sitting there on the ground, pretty much knocked out. So it's not too gruesome. Okay, so we got the usual things. We got a create event, a step event, and a draw event. But now what is very important, our cat object or player object is a child of the collider object. And this means, let's have a look at the collider here. This was the sprite of the collider. There we go. This is the collider object. And you can see here the collider has many children. It has its child is an object tree, the player, the object destructible, and the object ram. And the object destructible also has children, which is a stone block. So you can see here what's happening there. By the way, Object Collider doesn't have any events associated with them, but this is why you want all things that you can collide with descend from one object. In my case, it's Object Collider, is because if I can check for collisions with stone, I can check for collisions with RAM and so on. But of course, the more objects you have, you can't just keep adding each individual object name there. For example, if you're having a big game like, let's say, a Zelda-like, yeah, is the player colliding with a tree stump? Is the player colliding with a stone? Is the player colliding with an enemy? Is the player colliding with a different tree stump, for example? It just explodes there. Of course, this is not tenable to do this for all the objects, when pretty much what happens is each time the same, the player can't move because they are colliding with an object. And the cool thing is you don't have to just do it for each object individually, just for their parent object, because all those descendants, so if I'm checking now, if I'm on a tree, if I'm colliding with a collider, it says yes on a tree, this is true, because its parent is a collider. Same thing for RAM, same thing for stone block, and so on. So I don't have to write collision code for each object individually. I just check if it's colliding with something that's a collider, and everything is just descending from a collider. And if I want to be more specific, then of course I can check against a certain object name, for example. So if I'm colliding with an enemy as a player, or if I'm colliding with an obstacle, it means on the surface, actually the first thing is it means the same. It means my sprite can't go through there. But then, of course, when I know that I'm colliding, for example, with an enemy, yeah, of course, first now we have to make sure that we're not overlapping. But once this has been sorted out, then, well, if it's an enemy, we want to take damage. If it's an obstacle in the environment, we don't want to take damage. And of course, I can always check against those more precise or more specific cases. So just that you know that it's important to know that pretty much anything that moves and some things that don't move are descendants of the object collider there. Okay, let's have a sip of water first. We set the state, we set the sprite of the player, and the hit sound. So when the player is hit, what sound do they play? And this is the sound hit. Yeah, straightforward. So here I said health packs max. Apparently I set it, have a set value for maximum health packs and initial health packs. As we recall from before, the health packs, this value gets set each time depending on which level we are in, but we need just to initialize the value with something, and this is 3. And the damage multi, what is this? Multiplies the force of impact. We will see what this means when we get to collisions, but essentially when I'm checking the force of the impact, I'm just checking the speed in pixels per tick. I think it's the unit, and I'm just multiplying this by 4 to get how many health points we need to have to distract, no, to subtract, that's the right word, from the player's health. The player's max HP, the max health points are 100. And the next thing is also related to their health. This is just the health bar that's being displayed on top of the player. I'm just switching now back to the game here so that you know what is going on. Yeah, it's this health bar here on top of the player. Of course, it needs to have a maximum value, a minimum value, and needs to have a certain dimensions. And same thing for, where is Remy? I just lost Remy. But yeah, it's pretty straightforward what's happening. But yeah, you need, of course, coordinates for all this. Man, I'm zoomed in pretty far. So the health bar height is 10, its width is 96, and its Y offset is 140. This is the offset from the origin of the player. Let's have a look here at the player sprite. And this little crosshair symbol indicates the origin. So this is when I'm setting something at 0, 0 coordinates, this is the part of the sprite that adds 0, 0 coordinates. So, and the offset of 140 means I'm counting 140 pixels upwards to where I want my health bar to be displayed. And this would be, yeah, just above the head of the player character. So I'm scrolling up here a bit. So, of course, we want to show the health bar. Like I said, when we finish a level or fail a level, we want to turn off the health bar, and this is why I need this variable here that I can switch it on and off. Facing there is -90. Yeah, and here we are in a game maker territory because this is the facing direction, and directions or angles in game maker. Okay, now I need to bring up MS Paint again, because this took me a long time to realize how Game Maker measures directions, because it has its roots in platforming or making platformer games. So if we have here the entire circle, where would you usually start counting angles? Personally, I would start here at 0, and then go here, have this 90 degrees, and have this 180 degrees, and this 270 degrees, and this 360 again. Some mathematicians, I think, go counterclockwise. I'm not quite sure about this, but yeah, this is how you would things expect. Just to illustrate this here. We have here 0, 90, 180. This is not how it is, but this is how you would expect things, right? Okay, and now let me bring out the eraser, because I want to show you how it is in Game Maker actually. Can I undo this? Yes, I can undo this. Okay, so 0 is here. This is 0 degrees. And 90 degrees is here. 180 degrees is here, and 270 degrees is here. And now you can see a problem here. Or, well, it's not so much of a problem that's apparent, but Game Maker always clamps what you have between 0 and the value that's less than 360, so it's 259.9999. So if you jump, for example, if you want to make sure or just want to check if your player or something is, let me just pick a different color now, for illustration's sake. For example, you want to check if your player is between or is looking in this direction here. So it's between, let's say, 5, well, it's not a 5 there, let's say 5 degrees and -5 degrees. Yeah, with Game Maker you can't check for -5 degrees because, like I said, it will always clamp back to, and this would actually be not -5 but 355. So now if something And this is what I'm getting to is the problems that I had with this, because when you were the RAM is always homing into you, so you can't really check for ranges, because the range you have, like I said, if you're here between, for example, it's no problem if you're here checking for 95 degrees and 85 degrees, right? If it's just bigger than 95 and smaller than bigger than 85 and smaller than 95, you're in this here. But you can't do this here, like I said, because GameMaker always keeps it between 0 and 360. And this cost me a lot of grief, But we will get to this in a bit. But just to show you here what this facing direction minus 90 means, this is just for me that I know, yeah, it's here. So this is the facing direction the player is facing. So it's to us, towards us, to the camera. And this is what I more or less hard-coded in here. Cursiboo says something about math conventions here, as it is to be the same as game makers. So I've learned something new, apparently. Because, yeah, I recall something vaguely like this, but to me it always feels completely off, and I always have to look it up. So, next thing about movement is our dash speed. I implemented the dashing rather late, until I realized that it was important to the game. So the maximum dash speed is 25. I have no idea what kind of unit 25 is, but it's 25. And now we have a friction value. That's something that gets subtracted each step. Again, I'm not using delta time, I'm just operating on game steps there. And also the dash has a cooldown, as you've noticed, and the cooldown is the room speed. Again, this is also a value that's in ticks, and to get from seconds to ticks, I just multiplied by the room speed. So this is 60 times 1.5, so it's 90. So this is 1.5 seconds is the cooldown between dashes that you can do. And initially the cooldown is at 0, which means it resets again. So the cooldown has essentially finished. And the cooldown dash percentage is 0. Why do I need a percentage? This is also game maker specific. Like I showed you before that we have a health bar, and I'm also using a health bar for the dashing. And health bars, you have a very neat little function to draw health bars in game maker. That is just draw health bar, and then you provide some values. And the health itself is always a percentage. So you have to clamp your values or normalize them between 0 and 100. And this is why I'm using here this variable for cooldown percentage, because I'll be doing this in the draw event. So I need to have my values carry over there as a percentage, whatever this means here in the terms of the cooldown. So it's just, I have to do some calculations there and just to be able to carry it over. So this was dashing. Now for the walking. Walking speed, we have a friction of 0.7. So when you're letting go of, when you're just walking in a direction, letting go of the key, your player moves just a little bit, it overshoots just a little bit, and this is the friction, is 0.7, at which the player stops or starts to get slower. And the walking speed max is 4, like as you've seen here, it's just the maximum speed by which you can walk. And this, each frame, your maximum walking speed gets subtracted with 0.7, so it very quickly hits 0. So this is the friction of where you're going. And ac means the acceleration, so it doesn't hit 4 straight away, it just builds up 0.5. Then the next tick it's 1, the next tick it's 1.5, and so on. So after 8 ticks you have reached your maximum speed there. Again, this is just that it doesn't feel, the movement doesn't feel too linear, like it's just very computery, so it has a little game feel to it. And again, here the current direction, is the facing direction, because I thought you could of course be moving and looking into a different direction. This is most notably with top-down shooters, that of course you're strafing in one direction but you're shooting in another direction, and it's good just got an email. And it's good to have the facing direction and the actual movement direction decoupled to make things easier on you when you're choosing sprites, for example. Then again, I'm just creating here some flags: is dashing, is walking, and is alive, that I'll be using for checks later. As we've seen before, the game control checks if is alive is true on the player as well as on the RAM to know whether we have failed the level. The next is allow input and allow injuries. Again, this is something that's being set from the game control, that when you're dead, the game doesn't allow input. If you've finished a level, it doesn't allow input. And as we've seen before, it doesn't allow injuries to your character. So then those gets written externally. This is, yeah, I'm not quite sure if this is the right terminology, but this means those values are being set from outside the object itself, the instance itself. So those are essentially just public variables, and this is just to make sure, or to remind myself that I know that those are being set from outside for debugging purposes, because as we've all know, with scoping, just expose as much as you need for a game to run, or any kind of software to be able to debug. Because if everything is allowed to write to the variables of everything else, you invite yourself into a very special kind of hell. So those get written externally, which means do hit. This means is do being hit. So this when this is set true, then as we will see in the step event, it just sets a certain condition that okay, we can do now what's being done when a player is being hit. I hope this makes sense. So we are doing a hit, the effect of a hit to the player when this is true. Then hit force H and hit force V is the horizontal and the vertical speed. Game maker values the speed at which we are being hit. And this is the one, if you recall here, the damage multi. This is, we multiply the force with which we are being hit by this this value there. We will see this when we are in the step event. The grace counter and the grace period is something a little bit like the cooldown effect. Well, it's not a little bit like it, it is a cooldown effect, but I just call it grace period. That is for how long. In this case, it's for half a second. You can't get injured again when you've already been injured. We've all seen this in many games before when you don't do this and enemies just colliding with you, and you're taking a hit at each step. And yeah, this is what I wanted to avoid. So there's a grace period. As soon as your character gets hit, this counter gets a value, and the value is not 0, and then it just, like we've had it before, it decrements by 1 with each step, and when it is 1, well, the grace period is over. And also we have an alpha that's set and an alpha in it. This is for display purposes, so when you're being hit, the transparency or the opacity of your player sprite changes to 0.6, so it's halfway transparent. It's just like the flickering in the old games, just to let the player know. I mean, at least we who played games for decades now, for some reason we instantly know when something is blinking. As once we've taken a hit or a halfway transparent, we know that we are invincible for this amount of time. And the alpha in it is, of course, the alpha channel by which we draw this, and the initial value is 1, so everything is just opaque. So it's not actually the alpha, it's the opacity, but yeah, details. So the initial opacity, of course, is 1, and only when we are in the grace period, we're at 0.6, and then we switch back to the initial alpha. And of course, we have here global game player ID. Now we are writing here, this instance itself is writing its own ID, that is the handle. In other languages, you would have the address, the pointer to it. This one, it writes to the global variable that is global.game.player. The global variable of game is the instance of the game control, and in this instance of game control, let me just bring it up here again in the create event. So this is the instance of game control, and it says here player is a no one, and it sets itself here as soon as it gets created its own ID here, so that this one here, the game control, okay, switched over here weirdly, that the game control has a reference to the player object. Okay, so now what's happens here? We have a hit force horizontal and the hit force vertical, and then we got here external force horizontal, external force vertical, and external friction 0.9. What is this? Frankly, I have no idea, but I think we will encounter it in the step event. And the health packs, now we're setting here how many health packs the player should start with, well, the initial amount of health packs. And the hit sprite cooldown is 0, and the hit sprite cooldown in it is 20. What does this mean? Again, this is another cooldown, in this case here for the sprites. As we've seen here, I have a sprite here when the player is hit, and this just counts down how long we should be displaying the sprite of the player being hit, just so that you as a player have a kind of feedback that you know, okay, you've been hit, your character looks differently, and it's halfway transparent so that you know something has happened. And this is what this cooldown is for. It's just for 20 frames, for 20 ticks, it displays this sprite of you being hit. Then, of course, we need a controller, and the controller is the global input controller. I'm not quite sure if I'm using this. Apparently, I'm not using this, but sometimes, I mean, it's always good that if you have objects that aren't querying or aren't referencing your input control directly, you might want to have a layer of abstraction in between there. For example, now I'm always checking if the input control is input left is down or is left equals to true. You don't want this, for example, if you have a game where you're doing a recording function or a playback function, or you want certain entities to be steered by the AI, for example. So your controller shouldn't be always the controller, more or less the reference to the physical controller the player is holding, but like I said, a virtual controller. For example, if you're recording key presses for a replay function, and then you're doing the replay, instead of using the global input of the actual input the player is holding, but instead a playback input, and the playback input just goes for each frame, is left down, yes, is left down, yes, is left down, no. And yeah, you just change here which controller the player is using, or the player instance is getting its input from. And with just one line, you can make a very a cool replay function if your engine is deterministic, of course. But yeah, this is a whole different topic, but this is why I urge you, if you have something like this, just lay down a layer of abstraction between the controller of the player sprite and of the player character, and not do things like I did here, because yeah, this variable has never been used again, so I'm always querying a global.input. Yeah, the walking speed, this is initial walking speed is 0, the dash speed is the maximum dash speed, and input is no one, because I don't know why I'm setting here input to no one, but I think it's pretty much this controller here. I'm using input instead when I should have used controller. But I think as soon as we are in the game, I will be looking at the global variable to input to get somehow that this player has a reference to the input that's being registered in the global variable. Okay, thank you. There's something in the chat happening which is always throwing me off a little bit because I'm not used to looking at the chat, as many of you can attest. And CompuGenius program says, thank you so much for entertaining me with your quirky humor and quick wit. Oh, thank you so much. Apparently it's what I feel as humorous and witty is apparently coming off. Some people have said I'm annoying, most notably my mom. Anyway, thank you so much. Okay, and last thing where we are setting here is the colors. Maybe when I was debugging, I was just changing the overlay color of the player character. So the initial color is white, and when we are hit, I'm changing the color to red. I'm not quite sure if I'm still doing this in this version. But yeah, I'm just laying down the basics that I can or cannot change it if I want to. The color, of course, is the initial color, because you always want, if you change the color to something, you always want it to revert back to what it was initially, and this is why I always have, as you've probably noticed, I have a lot of, let me scroll up a little bit here, a lot of initial values for something here in it, there's another multi, there's another init and so on, a max init, that I can always switch it back. And HP, of course, is the maximum hit points, and we have here what I also didn't use, a last valid X and a last valid Y for collisions. Man, collisions are always a big headache with me, and for some reason, even after almost many years of doing this, I'm not quite sure if I'm doing things correctly, but I think I'm getting better each time, because depending on what kind of game you make, you have to treat the collisions differently. And this is why sometimes this pretty much was the reason why I switched to Unity midway through, because I couldn't get collisions working with this very patchworky approach of input that I had before. And I thought, if I just go to Unity and use rigid bodies, I'm good. Yeah, the collisions worked, but everything else didn't. Okay, so this was what variables we needed for the player. So what's happening on each step with the player? Let's just have a quick look here at when I'm drawing the player, what happens there. So first thing that I do is I set the drawing alpha to 0.5, and then I'm drawing the shadow. That's also a sprite here. Where do I have it? It must be here under right now. Yeah, there we are. VFX. That's shadow. That's just a brush stroke, a horizontal brush stroke. That's this dark green there. And it has its origin, its center point here. So this is just to make things look nicer. Like I do things. And the shadow is just being displayed at 50% transparency just below the player. Then we draw the sprite of the player at the current sprite index, which is just the sub number, the sub sprite, the number of the sub sprite. For example, if you have here an animation, it's just automatically place this animation flipbook style unless you do it manually itself. But like I said before, all those bright green values here are inbuilt values from GameMaker, so I don't have to for example, with those flipbooking, I don't have to pick, say, now we advance the animation frame by 1, next tick we also animate it, or we advance it by 1, and if it was the last frame we go to the first frame. I don't have to do this. GameMaker does it. All I have to use is image index, and it does it for me. Same goes with X and Y. Those are always the coordinates of my entity. I can't change them to somewhere else. Image X scale and Y scale is just how big the sprite is being displayed. By standard it's 1, and the image angle is the facing angle, and this is as we've seen, just always straight ahead, because if I turned it to 90, then it would be, the cat would be just laying on its side. So this is why I'm not using the image angle. Is always the same as it is. The only things that I change are the color and the alpha. As we've seen before, when I'm being hit, I change the color, but I'm not quite sure if this is in the final version still. And of course the alpha when we're on the grace period. And if show health bar, this is this dreaded draw health bar function here. You need to provide it with where it starts, how big the bar is, the pretty much just drawing a rectangle here. The value between 0 and 100 for the health, because in my game as a player you start with 100 health. This is not so much of a problem, so I don't have to normalize it between any values. And then of course the color of the background of the health bar. This is also true, means do we want to display the background, the foreground of the health bar at the lowest, and the foreground of the health bar of the color, not the foreground, the color of the health bar at the lowest and the highest, because it would draw a gradient between those. I don't need this, so I just specify the same things here. 0 means, I think this 0 is also a false. This is just a flag if I want the health bar to display a border around it. I think this is what it is, and the other 0 here is what kind of health bar. Should it be from the left to the right, or from the right to the left, or from top to bottom, and so on. I think maybe I'm switching those up, but those are those arguments that I have here. So if you're dashing, that means that if the dash cooldown is greater than 0, this means we are on the dash cooldown, because only when I'm dashing I want to display this cooldown health bar there. And now I'm here doing the dash cooldown percentage. This is how my rather convoluted way of getting the cooldown at which we are, because it could be arbitrary. I could say the cooldown is 45 frames, or the cooldown is 126 frames. And with this thing here, I always get the value, whatever it is, between the maximum and the minimum of this cooldown, as a value between 1 and 0. Probably you could do this much better, but I'm always a fan of doing just one thing or two things in one line, especially if it involves more involved maths, like here. I do it, you can see here, I do it once, this cooldown percentage, and I use it again here in the second line, just that I don't have a long line with many brackets there that are hard to parse visually if you just be looking at it once. So this is what's happening here. So I have now the percentage of the cooldown, the cooldown as a percentage where we are currently. Then of course the HB is where it is going to be displayed. So this is the health bar Y offset, but just offset a little further down below. So you can see here there's a lot of code just for displaying the health bar and the dash bar. This is only visible when we're dashing. And here, this I forgot to comment out. Draw text walking speed. This is still from debugging, and it draws it here in the room. So it's not on the player at coordinates 10 and 60 down. So usually this is not a problem. Usually this is not visible because, for example, if I look here at room game 2, no, this was exactly the one I was talking about. But here, when we're starting on this level here, you would see here on the top corner here where it displays the current walking speed. Same here with level 2, it's on the top corner here. So if you play the game and watch closely, I forgot to comment this out. So yeah, this is still in there. Okay, so this is what we're drawing. So essentially we're just drawing the shadow, the sprite itself, and the health bar. And if we are dashing, or the dashing is on a cooldown, we want to display how long it takes until we can dash again. All that's happening there. So what's happening now in the step event of the player? First, I have this thing here, do init. And this is like we've seen here with this state machine, where something happens only once and never again. And when I create something here, I say do init equals true. The reason, I mean, I could do this also here in the create event, right? Why do I do this here in the step event the first time the step event gets ran? Let's bring up Paint again. And can I have another instance of MS Paint? Yes, I can. Wonderful. Okay, the reason for this is when I'm creating an instance of something from another object, I want to inject some values. For example, if I have here my player, and this is the instance, by the way, this, let me just draw here, this is progressing time, and this is my create. Let's make this bigger there. Create. So this is all the variables that are here set in the create event. And for example, I say, just again for demonstration's sake, I will zoom in here a bit. Let's say health equals 100. But then again, when I'm creating this, I wanted to set my health to a different value as soon as I've created it. So for example, let's have here, let's call this a game controller, or just short GC. And this GC, this game controller, creates now this instance here. Let's call this enemy or so. Pixel Prophecy, how do you zoom into your screen? The question is. Good question. I have a little program which is called Glass Brick. Oh, look at this. It's my other window here. Wonderful. When I zoom out. Yeah, it's a little bit glitchy. And you can use your own shortcuts there. I use, for me, it's Windows key and Alt at the same time, and then just the mouse wheel to zoom in. It's quite handy exactly for this kind of screens. But yeah, with Mac, I think you can use a Control and then zoom in. So it's built in. But with Windows, I have to use a third-party program. Okay, back to where we were. So let's say I want to create an enemy, and it has standardly initially it has health 100, but now I'm having the game control and I want to create a couple of enemies, and I want some enemies to have a value of a health of 80. So when I'm saying here I want to create instance create, yeah, I'm just saying enemy, and let's say just 100 or so. Those are not the arguments that GameMaker takes. This is just some pseudocode to get my point across. When I say enemy 80, well, then it creates an enemy with 80 health, but the create event itself sets it back to 100. So my point that I'm getting to is that I can't change the values externally from what has been set here in the create event. But when I'm creating something, for example, I'm creating the player, and then it has all those initial variables set, and in the next line from another object, I want to change one of those things here, then this thing is changed. And then it runs here its first step event. And the thing here is now when I can say do init equals true, I can be sure that if something has been changed somewhere else in between creating and the first time the step event is ran, I can make sure that this always runs last. I hope this makes sense. If it doesn't, you probably are not very deep into the peculiarities of GameMaker. But yeah, this is just my way around it. Of course, you could also have some kind of begin step or end step. This, of course, would happen before the step, and this would happen right after the step. Just to be sure, if you want to have some things that are executed at very certain intervals where you know very certain variables have already been written or not. That's why I'm using this do init on a lot of my games. I'm having this do init flag here that says true. Then in the first step event it gets ran, do init, and then never again. So what is happening here now? I don't know when my player was created or not, but the last thing I want to do is get the input control. So get a reference to the global input control object that we have here, that we're always certain that there is an input control here. And the health packs get the health packs initially. So, and this is where I need this. As you've seen here in the create event, the health packs always get this from health packs init, but health packs init is set to 3. So I would always have 3 health packs if I couldn't intercept it. Thing is, it gets created with this value here, health packs init, it gets created. But then before the step event runs, the health pack init value gets changed from depending on which level we are. For example, it could be 10. And other stuff happens in between. And then the first step, this instance needs to be ran. It gets the health packs from the changed value already. So I hope I hope this makes sense. This is the only thing why I need to do this do init here. So then I got new X and new Y. This is classic collision code is, okay, so we have our coordinates from the last frame that are X and Y, and I call them new X and new Y. Those are our candidates for the next coordinates. Because as we know with collisions, you can't be quite sure unless you've really checked if your new coordinates are valid or not, colliding with something else. And this is why I'm storing what I have. I'm not working on those built-in values, because like I said, those are built-in values. When I say x plus 10, I can never get back to the value that was x before. So this is why I make sure I just make essentially just a backup, or my backup is my original X and original Y, which I won't change unless the very last thing when I'm sure that those values are valid. Okay, but we're not at collisions yet. We are just switching the state. Apologies. So we're the player state, we can see here in the create step, those are all the possible states a player could have. And when it is created, it starts out with the active once state, so the player is already active. So the first thing that happens here in the active once state is it switches over to active. So again, this is some superfluous code right now, but sometimes you want to do like I did here with this do init thing, that the very first time the player gets active, something special happens. Maybe they say yippee or so. That doesn't get run each time, each frame the player is active. But apparently I didn't have anything like this, so it just says active. Okay, so when the player is active, we allow input and allow injuries. That's all there is. But anything else then gets, like we've seen before, set from the outside. So if the player is dead for some reason, we are in the dead once state. And I show a debug message that just shows up here down below here in the log for debugging purposes apparently. And when the player is dead, well then they aren't alive. What a surprise. But again, this is alive flag gets checked each time from the game control. As we've seen, each step, it just checks if there are winning conditions or losing conditions are met. And if the player is not alive, well, that's a losing condition right there. Then, of course, we switch to sprite to the player dead sprite. We don't show the health bar anymore because we don't need it when the player is dead. And in the global game RAM state, this is a little bit fishy because now the player object looks up in the global variable and finds there here under game the object, the game control object. And inside this game control object, it gets the reference for the RAM object of the current level. And then it changes inside this RAM object the state of the RAM to RAM stating once. So the purpose is that as soon as you're dead, the RAM is not attacking you. I'm not quite sure that this is the place where to do this, because I mean, if we are, let me just open it again, good old paint there, because this is somehow overreaching there of our hierarchy. So for example, we have here the game control. Let's just, I'm always want to use shortcuts, game CTRL, and the game control is looking at player and looking at RAM, but they should be pretty much, oh, by the way, we also have here, this entire thing here, of course, is the global, the game itself, the global state. And here we have player, and RAM. And what we are doing now here, what this line, why it is so fishy, is, let me pick a green color here. What we're doing now is, instead of just saying yeah, or actually how it should be is that the game control should realize, okay, when the player is dead, it just looks at the player and then it, okay, if the player is dead, well, then we can tell the RAM it should stop attacking. But this is not what happens. What happens is the player looks up into global where the game control is and then gets a reference to the game control and looks into the game control where the reference to the RAM is. There it is, and inside the RAM it changes a value. So it's a big boo-boo. It's a big no-no how you probably shouldn't do things. But game jam code, there we are. It gets the job done in just one line, but it's just all over the place. Just friendly reminder. So this was only once when the player has died. Otherwise, of course, we would change the sprite each frame and also change maybe player sound each frame. So but as soon as the player is dead, we don't allow any more input and we don't allow any more injuries. Different thing is, but not that much different, if we have won the level. Well, first we don't allow input, we don't allow injuries. Again, this happens twice. We've seen it also happening in the game state, in the game control, that the game just makes sure that really no injuries to the player are allowed anymore and no input. And we just change the sprite here. It says heck to make this work at the end of this file. Oh, there's a hack to make this work at the end of this file. Okay, so when we scroll down, there will be a hack. It's good that I used all caps for hack there. And of course, when we've won once, just toggling those flags and changing the sprite and switching the state to 1. And yeah, there's nothing happening in 1. Okay, so those are the states at this point. So to recap, we set all our variables, we initialized them. We made sure that the number of health packs the player carries at the beginning are set to the correct amount, and we make sure that we are in the current state. And oh yes, we've saved or made copies of the current X and the current Y, because the next thing we are doing is movement. So this is quite a line here, but let's untangle this. So if we allow input, first, this is always important in GameMaker. When you're doing if checks, all those arguments you provide, all those logical statements, GameMaker checks them one by one. So if we know here that we have a logical AND here, and of course logical AND means the two things we provide need to be true. So if A is true and B is true, then the if statement is true, right? So, but if allow input is false, then it doesn't check any of those values anymore, because if something that is false gets ANDed with something else, the answer is of course always false, and this doesn't get executed anymore. So essentially, this is I'm just making sure that I'm really going from the most global state, or the most global statement, to more specific ones, so that if allow input is false, well, we don't need to check is left is true or is right or so on, because it doesn't matter that we really go through all those little checks there, because since we're not allowing input anyway, this is not important. But if we're allowing input and we're having is left or is right or is down or is up, essentially if we are allowing input and any movement keys are being pressed, well, then the walking speed, the current walking speed, is the current walking speed plus the walking speed acceleration. As we've had before, so if we're moving an input, we just, right now the walking speed is not concerned with in what direction we're going, it's just increasing the speed. And if we're not allowing input or no input is currently pressed, so it doesn't depend if your input is not allowed or you're just not pressing any buttons. It means there is no new input for movement. Then the walking speed gets diminished by the friction until, yeah, so this is essentially, if you push a button, you're allowed to push, you decrease the walking speed, and if you're not pushing anything, you decrease the walking speed by a certain amount. In this case, it is our friction, and increment would be by acceleration. Okay, but what if the walking speed is greater than the walking speed maximum? Well, then the walking speed is the walking speed maximum. And if the walking speed is smaller than 0, well, we have friction that is now below 0. This would mean we just would turn around and go in the different direction than we're holding. Then, of course, the walking speed should be 0. So again, this is just the speed of walking, but not the direction. So here I got some nice references to Sean Spalding's collisions code. Sean Spalding, I think he once worked at Ubisoft or so, and he's doing those great GameMaker tutorials of making a platform really from start to finish. And he's got some very nice code snippets there. So I urge you to check out Sean Spalding's channel on YouTube if you're in any way working with GameMaker. And chances are, if you are working with GameMaker, you've probably seen at least one of his videos anyway. Very, very good and very entertaining. So yeah, now we got HSPD and VSPD, and those I'm setting, of course, horizontal speed and vertical speed, and I'm starting here by initializing them with 0. Var means those are local variables. I won't be needing them outside here. I'm just needing them for the next calculations. Okay, so again, if input is allowed, so the following here, until this one here, let me just, oh, this was too much, make sure, end of if input is allowed. I've started a couple of years now doing this, that the end of those big blocks with curly brackets is just for myself, when I have like 5 closing brackets, it's really hard to keep track of when you're inside your program, what bracket belongs to what else. I don't have here nice folding options or collapsing options there in Game Maker. So I always, for myself's sake, I just put a little note after the curly bracket of what is it actually ending here. And I just have here some pseudocode. So at the end of if input is allowed. So everything, what happens in here is now concerned with input. So if -- dash cooldown is still greater or equals 0 and input is dash. Okay, so what is happening here? I have here already again a nice line of code. That's line of code comment at the end of the line of code that says dash cooldown has to be the first element in the statement, otherwise it would only be checked when the button is pressed. So we're checking what I said before is when you have a logical AND, and if you're just checking the first statement here and it is already false, then it doesn't check the other one. So we have to make sure first what happens here is whatever the dash cooldown is, we increment it here by 1 first before doing the check. This is a pre-increment, as you probably know what it is called. So I'm pre-incrementing the dash cooldown by 1. And if it is still greater or equal to 0 and the input is dash, then only then we react, we allow that we can dash, I think. So only react to dashing when moving is the next one. So first, this line here just makes sure that we are allowed to dash right now. And this one, because this is running each frame here, this is where the dash cooldown gets decremented. As we've seen before with the game control, where I'm just having the cooldown for are you allowed to push a button to trigger the next level. This is essentially the same thing here, just for the cooldown of the dashing, but this happens in this statement here. So each time this check gets run, it decrements this instance's variable by 1, and this is why this has to be the first thing here, because it decrements this by 1. Then it checks if it is greater or equal to 0. And if it is not the case, then it just skips over, or if input is dashing, or if you're not holding down or pushing the dash key, doesn't matter. This one still gets decremented by 1s, and this is why this has to be the first element here. I know it's a little bit confusing, but let me assure you it works like it should. So, okay, so we're allowed to dash, but we can only dash, of course, if we're already moving in a direction. You can't dash while you're just standing there. And this, again, I'm just checking if any button up, any directional button, any up, down, left, right is being currently held by querying the input. And if it is, then we play the dash sound, which goes like this. This was how I made the dash sound. And we create a new instance. And with GameMaker 2, I think you can't say instance create. You always have to specify either a depth at which it is created, it's like a Z depth, or a layer on which to create it on. As I've said before, I don't like using layer names because they always have to be strings, and when you in the middle of a development and change a string there, suddenly your layers don't work anymore. So I'm always using here the depth. Okay, so at which position I want to create this instance there, and what instance are we going to create anyway? Well, we see here, this is the object fx plume. So just to demonstrate here, I start the game now. And when I'm dashing there, let me switch off here Remy for a bit. When I'm dashing here and I hit space, I leave this little plume there where I was. This little cloud of dust. And this is what's happening here. Whoa, this is huge. I'm just creating this object at y minus 64. This is just not at the base of our, can you see this? Yeah, not the base at the sprite, but in the middle, somehow between the head and the legs, the feet. This is where this should be created. And depth -5 takes the current depth of the player, and -5 means it puts it in front by 5. I could also have used -1, but I went just to be sure with 5. And then of course we say, is dashing? Well, that's true now. And the dash speed is the dash speed maximum, because the dash speed, as the walking speed, gets diminished each frame by a certain amount, which we will see. And the dash cooldown is dash cooldown init. And now we can see here the dash cooldown must be bigger than 1. So, and as soon as it is bigger than 1 and is dashing, then this doesn't run anymore, I think. I hope so. At least, I mean, this is what it does. So this is the dashing. So next up here we have movement speed. I make here just a new temporal variable that says movement speed. And currently it has no, I mean, it should be movement speed equals 0 or something. I'm not really initializing it, but yeah, what the hell. So if we're dashing, the movement speed in this frame here is the dash speed. Otherwise, the movement speed is the walking speed. Makes sense here? The walking speed we have here already. So I'm just saying here movement is either dashing or walking. And if you're not dashing, well, then we are walking. And the dash speed here gets set by dash speed max, and the movement speed gets set here by, or the walking speed by walking speed max. So at this point here, we know that we are either dashing or moving, and the movement speed is set accordingly. Okay, so now if we're hitting left, if the input left, horizontal speed is minus the movement speed. Okay, so now we are taking the movement, the speed of the movement, and giving it some kind of direction to know where we are going. And left is just, minus, when you want to move something to the left, you just decrement its x coordinate. So this is why it's minus movement speed, and this right is plus movement speed. Same goes for the up, minus goes up and plus goes down. So this is the end of the input is allowed. So at this point we have V speed and H speed set accordingly to our movement. Accordingly, I mean, if we're dashing or just moving. So if we are dashing, well, then we need to diminish or just subtract the dashing friction from the dash speed. Otherwise we would be just moving way too fast for way too long. And this friction again here is set in the create event, the dash friction. I just played around with it. So I'm the increment dash, the initial dash speed is 25, whatever this is, and we are decrementing it by 1 each frame. So after 25 frames we are back at 1. So I'm just dashing for half a second. As we've seen here in the game, it goes really fast, and at first you make quite a jump and then you slow down in your dash. So exactly this is why this happens. Okay, and next up here, so and if the dash speed is less than 0 or equals 0, well, then the dash speed is 0 and we're not dashing anymore. So is dashing equals false. Okay, and now we are in the wonderful world of collisions. So place meeting, I always have to look it up in the help file. And place meeting can check for the collision with another instance, but it doesn't return to us the actual instance ID with what we're colliding. We can only say that we are colliding with something. But I mean, this is good. Like I said, always from the most generic to more specific, because I don't need to, for example, I don't need to find out or try to find out the instance ID, or essentially the address, the reference to the instance we might be colliding with, because first we want to find out, are we colliding, because only then it might be of interest with what we're actually colliding. So place meeting checks the following coordinates if we are colliding with something else. And here we have it, the object collider. So this means if we are colliding with anything that is the object collider itself or a child thereof. let me just open up the collider again and see here. So this checks here if we have a place meeting of our object at these coordinates with this object. So it means if we are colliding with a tree, the player itself, an object destructible like the stone block or the ram. So any of those that we are colliding with would be true. But what we are checking, well, new x, as you recall before, I just copied over the x coordinate that we had at this specific frame. So at this point, let me just make this a little bit bigger that you can see better, like so. So let's move down. So at this point we didn't change anything with the x coordinates, and the new x and new y are always, or didn't change. So far we only knew that we have a certain direction for a movement, and at this point where the collisions come into play, we are trying now applying this movement speed to our coordinates and check for collisions. So at the x position, let's add the h speed we just determined, depending on whether we are dashing or moving. So the horizontal speed on the x-axis at the y, so we're not concerned now here in this if condition with the vertical speed, just the horizontal speed. So if you're horizontally colliding with an object collider, or we're just trying this h speed to add to x. So what if, let's assume I would be moving 25 pixels into that direction. Would there be a collision? And if there would be a collision, then I set the horizontal speed to 0. So it means, yeah, you're not allowed to go there because this would be a collision. So I'm stopping you right there horizontally. Then next line is same thing vertically. Let's assume I would be moving down by 20 pixels. Would there be a collision? And if there is, the answer is yes, then the vertical speed is set to 0. You can see those, I'm treating those individually and not in one big statement, because maybe you're colliding vertically but not horizontally, then of course you still can move horizontally and not vertically, and vice versa, and not completely be blocked and not be able to move, because this is also a beginner's mistake or even an intermediate mistake that happened to me quite often, in the beginning at least, was, yeah, I'm checking for collisions, and if there is a collision, then you're not allowed to move anymore. And thing is, you start colliding with 1 pixel in just one dimension, and you're just blocked and can't move at all. So, and here it is, we're checking if there is a place meeting both horizontally and vertically, and only if there on both accounts there is a collision, then we set the vertical and the horizontal speed to 0. Those are just for diagonal things, and I don't think that this ever gets run, because it would already be handled by those place meetings that we have here. So, and now we can be sure. So like I said, once we assume that then we add a certain amount to our coordinates, and this would cause a collision, then this certain amount that we wanted to add to it, just make it 0. And at this point here, we're actually adding those h speed and y speed to the coordinates, while to the candidate coordinates that we have. The thing is now, so if we wouldn't be colliding at h speed of 25 or something, well, then x equals x plus 25. But if we were colliding with something, well, then we set the speed to 0. Then x would be still plus 0, the x that it was before. So next up, what if the h speed is not 0 or the vertical speed is not 0? So this means there is some kind of movement in any direction, either vertically or horizontally. Then is walking is true. So we're setting just the flag on our character. Yes, we are walking or moving in one direction or in other. And if we are not having walking, if we're not being moved in any direction, neither vertically nor horizontally, then we are not walking or not moving. Okay, again here, if input is allowed, Now this is a little bit different. First, before we were just checking if input were allowed for us, and then we would do walking and translation and collisions. But now we're trying to do to throw our bandage packages. And also we have to make sure that first is input allowed that we can throw this item. Further down in the game, I would, if I would be working on this, I would also make a check if we are allowed to throw an item. Sometimes you are not allowed to throw items. Best example that comes to mind is in Animal Crossing. You're not allowed to drop items on the plaza, and this is maybe something where you could tell the game, yeah, you're not allowed to drop items in this place, even though you are allowed to have the player input. They can push the button, but it just won't happen there. Okay, so if input is health, so now I understand what means is health. That this means the button for throwing the health for our RAM, the health pickup for the RAM, the bandage package. So if this button is pressed, that corresponds to the button that we press when we want to dispense one of those packages. Yes. Well, next, okay, this was the general case. Next, we can check, do we have even health packs anymore? If the answer is no, well, then we just more or less ignore the key press. But if we do have the health packs, then I just create a new throwaway variable that is item, and this will hold the reference to the instance we right now create. What do we create? We create the object item health. And this is this wonderful object here. And this one here is very short, just to show you. It has a value of 20. The value is how much HP it replenishes. Then an initial direction, an initial speed. It has also friction and a counter. And sorry, my nose is itching again, so I'm expecting rain tomorrow. So the health package, let me just show you in the game, also has a little bit of movement itself. So if let me just deactivate the RAM again. If I throw a health package, you can see it also slides a little bit there on the ground, and it's always going in a horizontal direction. So yeah, I've just run out now of those, but you can see they're just sliding a little bit on the ground, and this is why they also get some kind of friction and direction, and a counter of 5. Oh, damn it, I'm really sorry for scratching my nose that much. Okay, so what's happened here in the health pack? Well, again, the direction is the initial direction and the speed is the initial speed. Okay, again we have here green values, and those are built-in values, and with built-in values, yeah, I'm always a bit torn between whether I like them or I hate them, because on one hand, as I've outlined before, they save you a lot of time. You don't have to babysit all those values. But the downside is they take on a living of their own, a certain it's like a poltergeist in a sense. If you give you can't even use speed for anything else. For example, if I want to use speed more of an abstract thing, for example, let's say if I'm doing a game, just a management game where you have where you have to manage a newspaper, and speed is just one of those settings. How fast is your newspaper being printed? And I set the value of newspapers print or dot or the object that's controlling, for example, the newspaper printing, and I set its speed to 20. Then the object, the instance itself, would be moving by 20 pixels per frame or so. I think this is what the value is, would move around. I can, of course, use the speed for something else, but it always moves. When something has a speed, it always moves the instance around. Same for direction. It always rotates the sprite of your object, of your instance. And this is why usually I try to stay away from it, but here for the item where I don't do a lot of it, it works that I just give it a speed. This is the initial speed and the initial direction, and then have it do its thing. Again, each step I'm subtracting here the friction from the speed, and if the speed is not 0 but the speed speed is smaller than 0.1, so that it doesn't overshoot in a direction, I just set the speed to 0. So if it's if the speed is coming down to a margin of 0.1 plus, 0.1 minus, then I just set the speed to 0. And if the counter, again, I'm just moving the counter down, or because I'm having a counter here, and this is looks a little bit weird what's happening here, because I'm just checking if I'm having a place meeting at the horizontal speed I'm currently having here with a collider. Essentially, this was meant to check if, I mean, we are, as a player, we're throwing these health bandages, and health bandages are also bouncing off any colliders. But here's the thing, the player is also a collider, so the health package has a collision with the collider. And this counter here, this is why I start here with 5. This counter, just for 5 seconds, or not 5 seconds, for 5 frames, it doesn't do any place meeting things there, assuming that by this time it would already have left the influence of the player, that it wouldn't overlap with the player sprite. Thing is, this doesn't always happen, and this is why sometimes you drop the package right there where you are standing, and sometimes you can throw it in a certain direction. This just means where you're able to get within 5 frames out of the influence where the package was overlapping with the player, and that's pretty much it. And this one thing here, this is the most beautiful hack I've seen since I'm working with GameMaker. This means depth equals minus y. Just let me show you here in Paint. Well, let's make a new Paint instance. As you all know, the screen looks like this, and X starts, the origin is here in GameMaker. This is X and Y 0, 0. And when we are moving in this direction here, this should be an arrow. So in this direction, X gets bigger, and in this direction here, Y gets bigger. So this was the wrong palette. So let me just get my drawing shape here. So when I'm having my player here, and it has, for example, it's Y. Well, let's do this. Let's make this a little bit nicer. Again, wrong window. Let me drag this here on top. Let's say it is here at X30 and Y15 or something. And when the depth, like I said, always negative depth is in front of something else. So when I'm having, for example, a tree, that's, where is my thing here? When I'm having a tree at this position here, and its origin point is really here, and its origin point is here. When I'm having a tree there, that should, of course, occlude the player there. And this tree has... Where is my mouse? There we go. Maybe this sits at 28, and now here it comes, let's say 18 Y value. And of course, now 18 is bigger than 15. But if we minus, well, this doesn't work here. If we put the negative value of our Y coordinate in there, well, then minus 18 is smaller than minus 15. In other words, it would sort on top of it. And if you just take the room Y, that everything that is lower on the screen always sits on top of what is on top of the screen. And this is what depth minus Y means. You do this each frame, and just says everything sorts correctly depending on which Y, on which line, on which Y coordinate they are staying or sitting at right now. And this is so, I mean, this is so simple. Of course, I didn't come up with this. I just saw it and used it excessively ever since. And this is how I do all those nice little effects there, where players are behind trees and shrubs and so on. So you can see here, if I'm moving here behind this bush here, I'm just disappearing. Same thing here with the tree. And if as soon as when I'm very close here to this tree, you can see here where it's flipping over. essentially because the tree has its origin point right here, and also me as a player, and as soon as I'm going front or the back of it, then I'm just flipping there. And this is the reason, if you recall right at the beginning where I said some things need to be here on their own instances layer here. Some trees are instances and some shrubs are instances. This is exactly why. The tree also has a collider, as we've seen, so players can collide with it, and not just players, but also the RAM, of course, and those bandage packages. Let me just bring up here the tree. So the tree, when I create a tree, all you can see here, depth minus Y, and it draws itself here with a shadow. This is all. Didn't know why I didn't draw the shadow there. Oh, of course, that the player can walk over the shadow. That's why. But this is pretty much everything to the tree, and its parent is the collider. Oh, of course, yeah, one thing that's maybe important is you collide with the tree. Let me show you the collision mask of the tree. You only collide here at the base of the tree. This is your the collision mask of the tree. Everything else of the tree, this is why you can't walk behind the tree, because otherwise, if I make the collision mask fit the whole tree, yeah, it's a rectangle, right? You couldn't move behind it. And as for the player, same thing here. Let's just take the front walking sprite here. This is also the collision mask for the player. It's just this rectangle on where they are standing. And this is all there is to the tree. And the same thing here for the shrub. Where do I have it? This is, yeah, the shrub. I don't think that the shrub has here even a collision mask, but nothing ever collides with the shrub, because here, where is the collision object, the collider object, shrub doesn't even show up as a child of the collider. And if we look at shrub, the object, depth minus Y. And this is pretty much everything there is to it. And again, you can see here, those are placed on the instances. So all those things that I can drop behind or interact with are instances, and the other trees are assets. Those, you can see, are inaccessible to me as a player. Those are really just sprites. I can't sort on top of them. I can't sort behind of them. I can't even access their instance IDs because they aren't instances. They're just sprites sitting there. And this is, again, saves a lot of headaches and also a little bit of memory, because you don't have to have them as game objects there. And they are on their own layer. So this is why sprites are scattered among those different layers as different kinds of sprites. So yeah, this was it for this health pickup, and in draw it just draws itself. So now we are back here at the object player. We can move, we can do collisions, and we allow here the input. When the input is allowed, we allow the player to throw or create a new instance that is this little object, the bandage pack. So, are you still there? Twitch tells me that there are still 7 viewers, and I thank you so much for sticking with me for this probably rather dry subject there. But you're very, very good, and your patience is divine. And yeah, we're almost through with player here, and there is not so much different about the RAM. I think the most important about the RAM itself is, as we will see, is how it hones in on the player what its AI is, and it's very simple. Okay, let's here finish with the player here. So next thing here is the alpha. First, I set the alpha to 1.0, so it's always opaque. And then I'm just making sure, okay, are we currently in a grace period? So this means that the grace counter is greater than 0. Well, then let's also apply the grace period alpha, which is just that the player is halfway transparent. Then, next thing here, do we allow injuries? And this whole block here deals with injuries. Like I said, with do hit, this means do the effects when a player is being hit. For example, when the RAM hits the player, it writes into this player instance, and this is the thing why I said here, where is, yeah, this is in the player create sprite. This is gets written externally, do hit false. So when the player is being hit by the ram, do hit is already true. And the external force H, the hit force H and the hit force V, and or I think those external forces, they are all also being set by the object that collides with the player. So yeah, it's again, it's a little bit not very tidy, but again, it's really, it helps here. So I think it's the external force H and external force V, I think. Better Dash says, can't drop stream, your voice hypnotized me. Wonderful. Okay, so first when you're being hit, when we're doing a hit, well, let's set the grace counter up. So this only happens once, and then we're in this invincible state until the grace period runs out. Like I said, that happens here each frame. I'm just subtracting 1 here from the grace counter. So then we're merging forces. So the external force H plus the hit force H and external force V plus the hit force V. I'm not quite sure where hit force and external force V, where they are happening, but essentially it means that the forces here, you can see here, the damage depends on how hard something hits you. And how do we get this? My physics calculation is just taking the speed the object was currently moving on, the horizontal speed and the vertical speed, and just taking the absolute value, because of course it could be, the speed could be minus when they are moving, for example, left or up, then of course it's minus in the respective directions. So I'm always using here the positive, the absolute value, and multiplying it here with this damage multi. If you recall here in the create event, this damage multi here, it says multiplies force of impact. And this is what happens here. So, and here, so I'm just multiplying and collecting up here this external force that is actually the force with you were being hit, and as damage, and I'm subtracting it from HP. I'm not using health, because as soon as I write health, it becomes green and it is a built-in value. And as I've said just before, you want to stay away with it because it has unknown side effects. It just writes a debug message in the log, player damage taken, and what the damage was. And the color of the player changes to color hit. I'm not quite sure if this shows up in the game, actually, because I think it's just for 1 frame or so. And hit sprite cooldown is the hit sprite cooldown in it. And the hit sprite, as I've shown you before, of course you have to implement this. I want to display this sprite just for as long as this hit duration, hit cooldown is going on. So if we are not doing a hit, but we're allowing injuries, well, then the color is the initial color because we're not being hit. So yeah, we just reset the color there. So next thing is we allow injuries and the player is alive. So this is the generic case, the general case. And the hit points are less than 0. So we are alive, but the hit points have dropped below 0, probably from this hit here. So right after taking the hit and changing the health points, right after it, I'm checking, are the health points still bigger than 0, or in this case, is 0 bigger or greater than our health points? Well, then, well, we are not alive anymore. And the state of the player is now dead once. And the grace counter, well, is now 0. We don't need a grace period of invincibility when we are dead. So this is also something I took care here. So here it says external force, for example, when dashing or getting hit. Okay, so if the external force is, I'm not quite sure where this external force, frankly, what this means or where this is happening. Oh, right. Oh, now I know. External force means, again, I need to bring up this wonderful black whiteboard app that is called MS Paint. So let's assume we have here a colliding wall, and this is our player character that looks like an I letter. And we are dashing but we're dashing into this wall. So at this point here, we still have quite a lot of speed there, but as we've seen before, I don't want our speed to be, I mean, we could do this, but to have the speed to 0. But it would feel weird if you're just moving around like this, dashing and then bonk. But as soon as you hit something or collide with even 1 pixel of something, it stops you dead in the tracks. Instead, what it does should do is my very simple implementation at physics, and this is this external velocity. So when you're colliding with something, let's say this one here, what it does is first it checks, does the collision happen horizontally or vertically? In our case, it happens horizontally. So what are we doing next is we are keeping the vertical force pretty much untouched. You know what? I will try to draw this here via vectors. So this is the vector by which we are moving into this direction. We can divide this vector here into one that's just horizontal. That's like so. The horizontal force and of course the vertical force. So what happens now when I'm hitting a collider here with still this force applied here? All I do is the horizontal force, because in the horizontal dimension this collision happens, I just flip it. I reverse the direction, and now we're going, or I draw this here, now we're going into this direction back horizontally, but I didn't change here the vertical speed. So vertically we're still moving in the direction we had before, essentially resulting in this vector, and we are bouncing off. And this is our new h speed and h velocity for horizontal, and the vertical didn't or wasn't in any way affected. And you know what? The problem is now here there's another wall, and we're still colliding with it. But same thing as before, now that this is our horizontal velocity, then it just flips it again, and so on and so forth. And this is what I call physics for dummies, but it just works. It's not 100% correct, but it works for most of the time. And this is this external force here. And if external force is less than minus 0.1 or greater than 0.1, so only at a certain speed, otherwise it would just stop you. And if there is a place meeting with the collider, the external force h, here is what happens, is just flipped by -1. And that's all there is. And same thing here happens vertically, and so on. Otherwise, this external force is just 0. And if I scroll up here, where do I have it with the external force somewhere? Here again, the external force also, and the hit force that when you're colliding, for example, with the ram could push you. This is this external force. It would hit you at a certain amount, and then it would push you in another amount. And this is everything that happens here. And finally, at this stage here, of course, this I forgot to mention as I was here glossing over this. Once this is done, of course, we add this new external force and to h and y as well, or from h and y, this again to our new x and our new y, because again we made sure that there is not a collision, and if there is a collision, we flip it, so we are sure there is no collision on the other side. Of course, there would be an edge case where you are being pushed into something where you would be colliding on both sides at the same time. But I know that in my game, everything is relatively far apart, that you can't be pushed into a narrow opening anywhere. I would hope so. This is always possible, that it could just flip the direction of the dimension you're colliding with. And in the end, this is why I'm just adding it here to x or to y, depending on whether it's negative, it goes to the left and to the right, or up and down. And finally, our X. Now we can commit at this point. We know that new X and new Y are 100% solid and not colliding with anything. So we're just rounding here to the nearest pixel, X and Y, and this is our new coordinates. Okay, so now this was the movement, and here is just a little bit that is called display. It's not that much, it just lives up to its name, is concerned with displaying something. So direction is the current direction plus 360. This was my ham-fisted attempt at trying to get around this horrible problem here that I've outlined before, and it didn't work. It just didn't work. I tried to be very clever, and as you can see here, if direction is less than 390 but bigger than 360, and yeah, it didn't quite work, because like I said, with direction it clamps you to 0 to 360 no matter what. And I was using here dir as an intermediate value, and still in the end it didn't quite work. So essentially it was just concerned with, should it display the front or the back, and if you're being hit, it would display the hit sprite. And same thing here, if you're walking, it would use the walk cycle, or otherwise it would use the idle cycle, or just the idle frame from one excuse me, from depending on which angle you're facing. And of course we have here the hit sprite. If the hit sprite cooldown is greater than 0, then we do the hit sprite cooldown minus. And if the hit sprite cooldown is less than 0, we don't display the sprite of you being hit any longer. And finally, if state equals player state 1, this is outside of the of the state machine for some reason. It was very late apparently. Then I just flip the sprite over to player front happy. So no matter what direction they are moving in or facing in, when they have won the game, it's always player sprite happy. Front, this is important. Okay, yeah, this was the player movement. And I think I should get some more water. Unicorn, by the way. And again, thank you for sticking with me for this rather dry topic there. But we're almost through. Now we are looking at the RAM. And it has, in a lot of terms, similar code essentially. So the RAM has different states there. It can be attacking, it can be looking for a target. Waiting means it's just idle. Roaming once, I'm not quite sure if I used roaming, then it would be just moving in a certain direction for a random amount of time. Just wait there for a random amount of time and then pick a new direction and move there. I don't think I used this in this game. And then dead ones and saved ones when you manage to put it on this goal tile there. And here we have the running sound is the sound ram run. It also has a maximum speed, also has an acceleration, and this is important, a turn speed, by how fast it can turn when it overshoots, when it tries to hit you. It also has max health points. Again, I made things easy for me to keep the values between 0 and 100 by giving the maximum 100. And the target radius, how close the player has to be. Yeah, this is just in room units, or pixels essentially. So if you're in the radius of 800 pixels around the RAM, it will start to follow you, and if not, it will just flip back to looking for target, as it is. Yeah, just making here some sounds, or not making sounds, putting some references to sounds there. Red always is a number, and this is also numbers can also be sprites. You can just say them by name. For example, SBR_zone is actually internally a number, but GameMaker is clever enough that you don't have to use it as a sprite. I meant to say sprite, as a string, but all those red things are numbers. And same goes for sounds, they are numbered, room numbers, sprite numbers, and so on. Those are actually all numbers. Okay, so aim X and aim Y. This is, what am I doing here? Oh, I'm zooming incorrectly. let me just here reset my zoom size. There we go, that it looks much nicer. The aiming speed is how fast the RAM is aiming at the player. As we can see, I'll show you this in a bit in the debugging view. The RAM is not directly aiming at the player, but at a point somewhere between the RAM and the player. And this aim speed is how fast it updates this, or how closely it updates it. The damage multi is, of course, just as with the player. When the RAM collides with something, the player, the environment, an obstacle, yeah, its force, how fast it collides with it, gets multiplied by 3. Again, it has a hit sprite. This is this cute little sprite here when it gets hit. Same thing as with the player there. This also has a cooldown, of course, the sprite, I mean. And I also think it has a grace period of half a second when it was hit. Yeah, the health bar, excuse me, same. Huh. This doesn't sound good. Same thing as with the player. We need to have certain dimensions for the health bar. We need to convert the values to 1 and 100, 0 and 100 for the health bar, give it background, and so on and so forth. Hit force H, hit force V. Same thing as with the player, how much or how fast it was being hit. Then it also got a grace period, just like the player. It also shows its invulnerability via alpha. I can also say allow injuries, and it has here, in addition to is alive, a flag that is safe. And I made here this comment: will be checked by the game control to see if the level was 1, so that I know that, okay, when as soon as is safe equals true, then the game control will say the level was 1. So then we have here do init and do speed down, and this do speed down needs to be refreshed every step. I don't know quite what this means, but apparently we will figure it out when I see it, probably. Do hit sprite cooldown check true needs also to be refreshed every step. So I have to. This means essentially this refresh means I have to set it to true at each step, because at the end of each step, for some reason, it will be false. So as soon as I'm not setting it to true, well, then something has happened, and this is why I made a note here to refresh it each step. But we will probably see what this means. And do HP check is true. This is also that we are just checking the HP of our RAM at each frame. Then again, we register our instance in the game control as the ID. And again, last direction, last angle difference, those are some leftovers there, which I don't need. Then the color is white, and the sprite is the sprite of the RAM looking to the left and idle. And the state is looking for target once. So when it's much of it is like the player, it just has a different or additional values for states, and of course turn speed, acceleration, and that it has a radius in which it looks for the player. So yeah, pretty straightforward, I would think. Let's have a look at the step events of the RAM. Again, I'm doing here this initialization, and if I didn't do this here in the create event, again I do it here in the step event to set the first state of the RAM to be looking for target. And here in the tutorial, I have overrides, of course, for the tutorial, because you probably have noticed that in the tutorial the RAM will spot you sooner. I do this here by if room equals room tutorial 1, then we know we are in the tutorial room. So I don't allow injuries to the RAM, so it will always stay alive. Of course, that you can finish the tutorial. Otherwise, because of it's always bumping the scenery, it would be dead when you get to it. So I know this is a little bit counterintuitive when I'm teaching players the game and then they see that the RAM doesn't really take damages, but so far no one complained, so I think I'm good with this. And of course the target radius is 1200 pixels, so that the RAM I could spawn it from outside the screen, and then when you get to the second, or I think it was the fourth node block sign, this is what I meant to say, that it would start charging at you from outside the screen. And yeah, just a little reveal that this is Remy, and then tap, 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 he comes in. And this is why the target radius is different for the tutorial. Yeah, tutorials are always a little bit problematic because they are just a bunch of edge cases you need to litter about your rather clean code usually. Also, by the way, same thing goes for some kind of achievements. When you're checking for certain achievements, you're always littering, yeah, but if this has been done once, or if we count 1,000 of those, and so on and so forth. Okay, so let's switch the state here of our RAM. And yeah, it makes sense when the RAM is looking for a target. We start playing the sound of so if the running sound is already playing, because from the state it was in before, well, we stop the sound of this, because it has stopped and is now looking for a target. We change the sprite to it being idle, and the state is looking for target. So this is just once. The first time this looking for target runs, we change the sprite and turn off the loop of the RAM charging. Okay, so we are looking for a target. And what are valid targets? Currently in this version, it's only the player. First, we make sure that the instance of the player that is referenced in the game control actually exists. Maybe I've messed up something, maybe the player died and I despawned it or anything like this. This never should happen, but if it does, it's good to just double check. So if the instance of the player exists, then we make sure, is the player alive? Because you've probably also have this in your game dev, that you have monsters attacking the player and then the player dies, but the monsters just keep pummeling that bloody corpse there. And for my game, I thought, yeah, if the player is dead, I don't want my cute little RAM to keep pummeling the player there that's just sitting there dead. So if the player is alive, so if the player exists and he is alive, or they are alive, yeah, then let's calculate the distance, because otherwise it wouldn't make sense to calculate the distance from the RAM to the player if we are not using it for anything. For example, if the player is dead, because we don't attack the player, it doesn't matter where it is. So, but the player is alive, so we find out the distance, the point distance between the current coordinates of the RAM to the current coordinates of the player. So this is our distance. And if the distance lies within the target radius, well, then we can set a target. And the target is the reference to the player in the global game state. And of course, we switch the state. We found a target now, and we can switch the state to attacking once. So this is when we are looking for a target. Next is if we have a hit sprite cooldown that is less or equals 0, well then we don't need the hit sprite when the RAM is being hit, you know, like this with those little lines. We can switch it back to the idle state at this point. And also when we're looking for a target, we do the speed down, because maybe the RAM was charging before, and the do speed down is that it's just tapering out. It's just getting slower because you don't want to stop it right there in the tracks. It's just like you let it go. And of course we need to do the HP check, because now we're in the game, and even if the RAM is not targeting the player and is looking for a target, we still need to check its HP. Okay, this is when the RAM is looking for a target, and as soon as the player is within the range, then it's attacking. So when we're attacking, the sprite we change to the running sprite. So now the RAM is charging and the state is attacking. And we start here the audio loop of the RAM charging. This sound essentially, and true means that this loops, and I even have here this debug message output that just says attacking, that I was aware of it in the development. Okay, we're here in the state of attacking. So first thing is, does our target exist? When we attack, we want to make sure that our target exists actually. What I didn't do here actually is, if our target does not exist, that we switch back to looking for target once. This is something that actually else, maybe we should do this. State equals RAM state looking for target once. I think this is safe to implement this there. Okay, so if our target exists, we need to take aim. And this is the big secret behind the AI. That is, I'm doing lerping. I'm lerping, and I have here the aim X and the aim Y. So let me, before explaining this, let me show you what this looks like in the game. I think I'm still here in the debug version. And let's deactivate here the RAM. This was a little bit too slow. But you can probably see here this white dot here underneath the player. This is where the RAM is targeting me. And this is lerping or linearly interpolating to the player's position by a given amount. And the amount is very small, so it's just a small step between each frame there. But this is what the RAM is actually targeting, and this also tells how fast he can turn around when he overshoots and so on. Let me just try it here. Switching now. Can I go through here? No, I can't actually. Yeah, really took my time here. So. Okay, here we are. So I switched the RAM back on, and you can see here it follows this dot here, and once it overshoots, it turns at the given turn speed and then tries again. And also if he hits me as the player, it moves me around, and also he bounces off back again. And now I've wonderful, getting lots of emails today. And now it's just running in circles, but as soon as I move here to the side, it will probably hit me again, and I didn't make it. So this is what this lerping here means. This is the aim X and the aim Y. And also here in the draw section here, this is if is not release build, then it draws here this aim circle. So. And the aim speed, let me just see here in the creative event where we have the aim speed. Yeah, it's 0.05. So it's just linearly interpolating between the aim, the current aim, and the target, and just moving it each frame just a little bit more into the direction. So after, as you've seen it, after a second or so, it hones in to the player if they're standing still, and if they're moving, then it's just this little dot that they keep chasing, much like a cat. And here is, like I said, I had the biggest problems here because, of course, you had to turn the actual instance of the RAM, and you have to react it, or well, not react it to the player. Essentially, just to have it turn that they always would go towards the player or towards the target. And my problem was that I tried to do this by setting the angles, by calculating the angles directly. And as much as I enjoy having them between 1 and 360, which is very straightforward, if you're not coming from mathematics. But like I said, this clamping, as soon as the player was stepped over from being 359 to like 2, then the RAM would go a circle around it and then hone in. And I had a lot of weird problems because of this. And the reason, or how I solved this, was not using the actual angles themselves, but just the angle difference, because now it would always pick the difference and not a fixed absolute value, and this made it much easier just checking for a certain angle difference and not the absolute values. I think I said the same thing 3 times now. So the angle difference, let me just bring up here the help. What it says, this function will return the smallest angle difference between 2 angles at a value between -180 and +180. So and this is so wonderfully helpful as soon as I found this out. So we take here the direction, again it's this built-in value of where our RAM is currently facing in, and to the direction, the angle to the aim at the position, the point direction between our current position and the aim. So, and from this, if the angle difference is greater than 0, well, then we subtract the turn speed from the direction. Otherwise, we add the turn speed from the direction. Turn speed is here 2.5 degrees, I think, per step or per frame. And this is essentially it. Really, this is all there is to the RAM that is attacking. It is aiming at something, and then this is its direction, and here we see then it just adds here the movement speed, and this is all that it does. And this is why it is always so dumb that it is just trying walls head on, because there is no A-star algorithm or anything. Really, it's just this very dumb almost missile homing like intelligence. I don't want to call it intelligence, behavior. Let's call it behavior. Okay, so if our target exists, well, then we hone in on the target. Otherwise, we just switch back to looking for target. And the speed, again, this is the built-in value. Like I said, if you have something, give something a direction, the speed, it doesn't matter what it is, it will move around. But I think, like I said, at this point, I doubled down on using the built-in values of GameMaker, and it was good. It was okay. So we have here the speed is just the current speed plus the speed acceleration, because it will accelerate its speed, as we've seen here. Where is my speed? Oh, there it is. It will accelerate by 0.5, so that when it bumps there, or just you slow it down by throwing a health package, then it doesn't charge at full speed right at you. So it has a little bit of speed build up. And of course, if the build up exceeds the maximum speed, we will just floor it at the maximum speed. And of course, when we are attacking, we want to do the HP check. Like I said, this I have to refresh at each frame, and this is why it is happening here in the attacking. Again, this state gets, everything in here gets run each frame. And each frame I say do HP check true, so that each time we will really do this HP check. We will get probably to HP check later, where it will set itself to false. Okay, so if hit sprite cooldown is greater than 0, this means we want a sprite to RAM to have this. It's just the other sprite, that it's not the hit sprite but the running sprite. And again here, each frame we check again here the distance of how close we are to the player, and if it is still close there. Again, this probably should be somewhere here where instance exists target. But again, I'm using now here player and not target anymore. Yeah, probably because I was running short on time and I had completely forgotten that I should probably put it in there if target exists, because it doesn't always have to target the player. At least that's the idea. Okay, so if the distance exceeds the target radius, there we go. Then the target is no one, and the state, yeah, this I think this is what I did here. pretty much target no one. That's a 1-0 too much. There we go. Ah, damn it. Sorry about my itchy nose. It probably looks a bit red already. Ah, yeah. I don't know why my nose is always this itchy. Okay, so this was what happens when we are targeting something. And here I have waiting once and waiting. This is just idling. This is when waiting once, it just puts the sprite to idle and the state to waiting and stops any running sound that there may be. And when we are waiting and there is a target near, you know what? I'm not quite sure why I have this waiting here, because essentially it's the same thing that it's doing as when I'm looking for a target, right? So yeah, I'm not quite sure if this ever gets run or if this ever is being used actually. Like I said, it's waiting should, at least in my mind, waiting should be when it's not even looking for a target. So I don't think that this RAM state waiting is ever used once. But what is definitely being used is the RAM state dead once. So as soon as the game, as we know that the RAM is dead, we stop any running sound that there may be. And we change also the sprite to, of course, the dead RAM sprite. We don't show the health bar anymore, we don't need it. The next state is just dead, and of course we don't allow any injuries because it's just cruel hitting a dead animal. And when we are dead, I'm just making sure here that the sprite each frame is being set to the dead RAM. I don't know why, I just wanted to make sure. And we also do the speed down, which means we just let it run out when it was charging it, and it's dead. It's just this corpse sliding to a halt. Yeah, and here is the speed down that says if the speed is less than -0.2 or greater than 0.2, so speed can be also negative when it's running in a different direction, then we just multiply the speed by 0.9, otherwise it just is 0, so that it doesn't overshoot in a certain direction and then would end up in a pendulum motion. This is why I'm using this dead zone here between -0.2 and +0.2. So if it falls somewhere there in between, then we just say it's 0. And then also this part here doesn't run anymore. And then we say do speed down false. So this is why you always have to say speed down equals true when you want it to have it, because it sets itself here to false. Yeah, same thing here with this hit sprite cooldown is still greater than 0. Well, then we do the cooldown, unless then we don't need the cooldown. Yeah, again, this is do HP check equals false. This is why it needs to be refreshed each frame, because it sets itself to false after it has run. Again, if the HP is equal to or less than 0, then it's not alive, and we switch the state to dead once. And as soon as is alive equals false, this is the value that our game control is checking each frame. So if the RAM is not alive, then it triggers the losing condition of the level. Okay, collisions, pretty much the same thing as with the player, but here we are just using the built-in values. So if we have a place meeting at speed with a collider, I'm just checking here horizontal first. Then this is the difference between place meeting and instance place. As I've said before, place meeting just checks if there is a collision with this object, and instance place is a little bit more costly, but it returns the actual collider, the reference to the actual collider, the ID. And this is why we can work with it here, because now, okay, we know there is a collision with a collider between the collider and the RAM. Okay, so here now we check, okay, is the collider the player? Well, if it is the player, then here we go. We write directly into the player, and this is, not so good, but okay. Then we write directly into the player, do hit equals true. And now we also give it the hit force horizontally and vertically. This is the current speed by which the RAM is traveling. So if the RAM is very fast hitting the player, it also transfers its speed or this force to the player, and this will be the basis for calculating the impact, the amount of health points the player loses when being hit. It's just summing up the horizontal force and vertical force, multiplying it by the damage multiplier, and this is how you get it. Okay, so maybe there is a collision, but it is not with the player. Well, it doesn't matter. Well, it does matter actually. So first thing is here, I just want to make sure, is it the player? I could have written this differently, but apparently I went for this kind of nested version of if and switch statements, but here we go. Okay, so if you're colliding and it is the player, well, then register the hit with the player and tell them how hard they were hit. If not, and here now let's find the object index, which is just that we can identify which kind of object we were colliding with. Again, Collider has a lot of children, if I find it, and we are just trying to find out which kind of child we have. It's not the player at this point, but perhaps something else. And here I have two cases which are pretty much resulting to the same block. If it's a destructible or a stone block, essentially the stone block is a destructible, so yeah, it didn't quite need this statement here, but either way it's made for post-jam modifications. So if we're colliding with something and this collider is a destructible stone block, then we take damage. At this point we are the RAM. So let's find our current speed, both horizontally and vertically, just the absolute values. Like I said, if the horizontal speed is negative, it just means that we're going left. So we want, of course, the positive values of both and multiply it by the damage multi. And then we register or set the flag that in the collider, that the collider got hit. Whatever the collider is, it needs to have this variable here instantiated, or not instantiated. Instantiated. I think, no, it's not instantiated. What's the word? Initialized. There we go. Something with I. So if the collider doesn't have the variables is hit or damage in its create event, this game will crash. So yeah, just to be aware of that. But our destructible has a value, has a flag for is hit and damage. So we just take what damage, what current speed we have multiplied by the damage multiplier and give it to this object we were colliding with. In this case, it's the stone block, most apparently, yeah. And we tell also the stone block that it got hit, because the stone block will do something when it got hit. And here we are, self-damage. So this is at this point, we just said there was a collision. It was maybe with the player. If it was with the player, we tell the player how hard it got hit, how hard they got hit. If it was with a collider, like a stone block, we tell the stone block that it got hit and how hard. And also, well, we need to take some damage ourselves. In this case, we are again the RAM. So we say is hit equals true, and the hit force is the horizontal speed. I'm not quite sure why I don't use the vertical speed as well, but I think maybe this was for testing purposes. I'm not quite sure why I'm doing this at this point, but yeah, anyway, and we say hit equals true, and I'm not quite sure if I'm using hit anywhere else. Oh yes, I do. So is hit true and hit is true. Game jam code, I'm not 100% certain what this means, but yeah. And now here we have the bounce off. This is the same thing. Do I still have it open? No, I don't. This is the same thing as with the player. It's just that the RAM just bounces back. So whatever the value for a horizontal speed is, when I'm having here this horizontal collision. Oh, now I know why I'm only using this horizontal collision here. You see, this whole block here is just for horizontal collisions there. So if I'm horizontally colliding with a player, horizontally colliding with an object, anything hit equals true. This is why I'm using this, and this is why I'm only using the bounce off here horizontally. So I'm just multiplying the horizontal speed times negative 0.6, so we're losing some energy there. It's not this perfect like metal like bounce off effect, but yeah, there's a lot of friction involved, and this is why we're not bouncing off at a value of 1 of our horizontal speed. Yeah, again here the very same thing, I just copied over pretty much the code from above. Same thing here going for vertical. And this is hit equals true. And why do I use hit equals true when we have here is hit true? It doesn't matter if we're hit horizontally and vertically, we only, or both at the same time, we only want the sound of the hit to be played once. And this is why I'm using it. So I'm just playing here the audio hit sound once, and this is also, I didn't implement anything more advanced than this to avoid this buildup of sounds when there in each or every second or every other frame there's a collision happening. This is why the audio is building up, and this during the tutorial most notably it was a little bit straining on your nerves. Okay, so those were the collisions and the bouncing off the collisions. By the way, you're doing very well. We've almost made it. What if we are having a place meeting, again a collision with an object of the type pickup? Again here object pickup, I'm using it as more or less a class that the object item health is derived of. Again, Game Maker is not that much object oriented, but you can somehow make it work as I do. And my nomenclature is pretty much when I'm writing something here in all caps like pickup or zone or destructible, it's the abstract base class of something, and here from pickup the object item health is spawned from. Or yeah, let me get back to my RAM here. So I'm just checking if there was a collision with a pickup. I don't need at this point I don't care what kind or what's the ID actually is. I just want to know if there is a collision, and if there is a collision then I can switch it here and with the instance place. So first I just check if is there a collision with a pickup. If no, well then move on. And only if there is a collision with the pickup, I care to find out the actual instance ID, the reference to the object that we are collided with. So far, I mean, there's a switch statement with only one case in there currently, and this case is it is a health pickup. So this is what happens when we pick up a health pickup. We add the value of the collider to our health points, and this is very straightforward, right? And also we have to make sure here, this is in the next line what happens, that we can't overshoot our maximum health. And I could also write this in a different way. For example, I could also write this if HP is bigger than HP max, then HP equals HP max. Well, not MP HP max, but it's much faster, well, not faster, but easier to write. I just take the minimum value of HP or HP max, so whichever of those two provided arguments is the smallest HP it will become. Then I got here to do sound. Apparently I'm not using here any sounds for pickups, or look at this, actually I do, so this to do can go. And of course I need to destroy the pickup that we just picked up, otherwise it of course would still be sitting there. So I'm destroying the pickup, playing the sound for the pickup, and here is some funny little hack. I just set the speed to 10% of whatever the RAM was currently at, so just to slow it down, which made the later levels especially easier to work with, so or as a player I mean. And finally here we just check if there is a collision with a zone. Currently I only have one zone. This is also here why the switch statement is very short. So if we are in the goal zone, then we set the flag is safe to true, and again our game control checks inside the RAM if the is safe flag is true, because if it is, congratulations, you've won the level. Now here for display stuff, again we set the color to white. because when we are being hit, I set it to red when I was debugging or developing it. Alpha to alpha init. Again, it's just for the grace period that the sprite is 100% opaque again. And here, let's do something when, as long as we are still alive. So this is here the end of is alive, because we don't need to do a lot of things when we already know that the instance in the game here is not alive. Let me just reset here the view size. Yeah, this looks better. So, if we are alive and the grace counter is greater than 0, well, of course, yeah, this is the grace period. This is where we have our sprite just at 50% opacity, and at this point we can say is hit equals false. As long as the grace counter is greater than 0, we don't allow it to be hit. So this is why we always set it hit is false. Okay. Then we are alive and is hit is true, so we can't be in the grace period at this point. So if we don't allow injuries, then we also negate it and say is hit false, and the hit force is also 0, 0. So there was no hit, there has never been a hit, fake news. Okay, but if we are hit and apparently we allow injuries, okay, well, here we go. I got this one script in the entire game, which is just more or less like a function call in a sense. And this says script debris hit. And it takes 4 arguments, x, y, the coordinates, 4 and 0.07. So what does script debris hit mean? Here I have this one single script here. Let's open it up, and it's also very short. So the first argument, just the coordinates x and y, the count, the number of debris, or what's the plural of debris? I don't think there is a plural. And the completion step, how much of this has been completed. And for the count, we're just repeating this. We are creating new instances. And which instance do we create? An instance of the object, or of the object fx fragment. And the I completion step of this, we have to look at this object fx fragment. And where do we have object fx fragment? Yeah, it's just this one little pebble there. It's this very, very small sprite. And here, this is its initialization code. In the end, all this does is it draws this sprite, gives it a certain direction and a certain speed and a certain scale and a certain rotation, and then and a certain completion. And then in the step event, it just lerps the completion. So the alpha between the initial alpha and the final alpha, and then just draws the completion, how far it is in its lifetime, essentially. The scale, the same thing, initial scale, ending scale, color, rotation, and speed. So essentially, this is my attempt at a particle system. And like I said, and if the completion is greater than 1, so since we're lerping from 0 to 1, if you're greater than 1, it destroys itself. Yeah, this is not really good for garbage collection or anything. You would want to have some kind of ring buffer for this. But yeah, and completion is, as you can see here, each step, it just adds here this completion step here. It's just a value that I've toyed with. But essentially, yeah, you give it a starting color, an ending color, starting alpha, ending alpha, speed, and so on. And it draws this sprite itself essentially multiple times. And this is essentially what is happening. Where do we have it here? In this debris hit script here. So yeah, I'm just creating here a couple of objects, a count. How many do I do here? 4. So I'm just making 4 little stones and set a completion step. The bigger this value gets to 1, the faster this one will happen. So you want to keep it between 0 and 0.1. And yeah, and for the number of things, this case 4, we just create 4 of those things here and set the completion step to 1.0. And this is the debris effect. We can it for shits and giggles, set it to from 4 to 40 and see how this looks. So when our Remy is hitting the stone, yeah, or hitting pretty much anything, you can see here, it's not the stone, but whenever he is colliding with something, it's really spawning 40 of those little debris dots. And this is what's happening. So when each time he's being hit, he spawns this thing here, and this script just makes sure that it spawns the right amount of effects sprites. So we don't see it because it's only for 1 frame that the color is set to red. We play the damage sound of Remy, and of course the damage itself is, as we've had it before with the player, we just take the hit force, the force with which we're being hit, the horizontal and vertical, add them both up and multiply it with the damage multi, subtract the damage from the HP, write something to the log, change of course the sprite to being hit, start the cooldown for the sprite, start the cooldown for the grace period, and reset here the force to 0 and say, yeah, we're not being hit anymore. And finally here we're just doing the display. So if we are alive and our target exists, if the target is smaller or if our x is less than the target x, it means we are to the left of our target. So I'm just scaling the image of our RAM. As you can see here, is always looking to the left, and when we are to the left, well, he needs to be looking right, and all I do is I just flip the sprite, and this is what is happening here. If we're to the left, I flip the sprite, the x scale by -1, and otherwise I still do it by -1 again, because apparently for some reason this works. I don't know why exactly, because I thought it must be, of course it was -1 before, and then it is -1 again, so I think this is how it works. Anyway, and lastly we have our favorite friend here, depth equals -y, and I zoomed out way too far. Sorry. And this is it for the RAM. If we draw the RAM again, you can see here we set the alpha, just draw the shadow, we draw the sprite of the RAM. If we need to draw the health bar, we draw the health bar. And if we're doing debugging, we draw the circle of his influence, of where he is looking for the player, and the little dot for the target where our RAM is targeting. And I think this is it. Let me just see here if I have something else here in my little objects, but we've seen the initialization, the input, the actual game logic, what the player is doing, what the RAM is doing, collider, health pickups, other pickups, how trees and shrubs are being sorted. The goal zone, again, I don't think there is a lot in the goal zone. Oh right, yeah, we can look at the stone block, because if you recall, the stone block needs to have 2 functions, or in my case I'm using flags for functions, and then in the step event I'm just checking for those flags, and the flags are is hit, and I think this was the only flag that I'm using, and damage, of course. So yeah, each stone block has a certain maximum HP, has an initial color, a color when hit. I think I use this for debugging purposes, a sprite, and even an image when intact and an image when fractured. And I can show you here in the sprites. This is the stone block here, this is the image when it's intact, and this is a sub image when it is being fractured, so that it just switches between those. And here in the step event, so it's also very short, when it is being hit, the stone, like anyone else, has HP, so we subtract the damage. Then we change the color, apparently it's still there, but I'm not quite sure why it doesn't show, probably because I was overwriting it just down below. And you see this beautiful thing here. It's again our script where it creates debris, but this time not just 4 of those little pebbles, but 10 little pebbles. And it used to play a sound, but I'm not quite sure why it doesn't do this. And when this is done, when we are not hit anymore, we reset the damage to 0, because this damage was also set from the outside. If you recall, when our ram was hitting the stone, it set in the stone the amount by which it got hit, and the flag to is hit to true. So otherwise, if it's not hit, well, the color is the initial color. And if the HP are less than the HP maximum, all right, as soon as the stone is not 100% intact anymore, we switch from the original image, that is the intact image, to the image fractured. And yeah, of course, if the health points drop to 0 or below 0, we create a plume again, just like when you were dashing, but the stone also explodes in this little plume, not bloom. And yeah, it creates this plume at depth also -5 that it sits in front, and it creates a debris here. And what is a debris? It's object debris, and this is the sprite it leaves behind. This is just some pebbles there sitting there on the grass. And this is what's being, it just creates this image there, or it's not an image, but it's more or less an empty game object that just has a sprite, because it doesn't need all those logic here anymore. Then it plays the sound of the stones crumbling and destroys itself. So again, this stone debris, this was the sprite. I'm looking at here the stone debris object, not the sprite, and you can see here there is nothing to it. It's just a sprite here. It doesn't even have some kind of sorting for depth or anything. So apparently, yeah, I completely forgot about doing that. Yeah, this fragment, we had fragment, stone block. Yeah, again, and the depth sorting. This was the stone block. And the info box, this might be interesting how I did my tutorial. Yeah, this only happens here in the tutorial and one level to the last. And when I create it, I did what I dread to do, that is text boxes. I think I've mentioned it a couple of times. I hate doing UI coding with GameMaker, because you pretty much have to do everything else. In Unity you got this wonderful canvas system and Text Mesh Pro, and pretty much you can just format your text there in RTF style. It's very friendly, and here you don't get this. So here I have this text box here. Well, this info box here, but associated it has this little text box it displays, if you recall there from the tutorial. Let me just quickly show you. This is why I can here is release build. Let's set it to true. Then we will start right into the tutorial level, just as a refresher. So here this is this text box here, and as you can see, it is centered at the top. Also the text in itself is centered. It has this blue semi-transparent background there, and there is little text being displayed, and as soon as I'm not colliding with it any longer, it just disappears. And this is what is happening here. Yeah, I'm just, those are the calculations. A box is an array with 4 entries. And this is, just the coordinates of the box, essentially. And this is the box height, the width and margin. And yeah, those are just calculations. That is, everything is pretty centered. So that if I'm toying around with those values, that everything is very centered, and margin is just the margin from the top. And pad is the text padding. So the text has also here a top, center, bottom, left and right. And this is just more or less derived here from the box with additional padding. And the center is here hard-coded, the game's dimension of 1920 by 1080. And I'm just taking this one and dividing it by 2. Then we got the dash key and the bandage key. You can see here those are strings, and why did I use them here as strings and not hard code them? The thing is, I think for dashing I didn't use space but shift, and when you hit shift multiple times on a Windows, I think I've deactivated it now, but then what pops up if you have tried it on Windows is this what's it called? Just some screen reader assistance, and it makes bleep sounds and asks you if you want to switch over to some easy reading mode or anything. And you were hitting, when you're playing it, you were hitting a lot of dashing buttons, and this is I thought I was toying around with a lot of different key combinations, and I wanted to keep it modular or easily interchangeable, and this is what happens here. Okay, the next one is a little bit ham-fisted. This is an in text array, and I started here by -1 so that I could enter, so I didn't have this. I mean, you can see this one will be 0, this next 1, 2, 3, and when I want to enter something here, or at least a new entry, I don't have to reserialize every subsequent entries there. I just need to copy and paste it. But it's not the best thing here, because for each text entry, you can see here I have a line of code that is essentially a string here. And line breaks are just \n, as we all know it. And it just tells you what the game does, or how to play the game, and text 20, that concludes the tutorial. And message string and info is 0. Step is just, if the player is colliding with the sign, then it says info equals 10. This is a special case. Then do display is true, so the player collides with it, display is true. And if display is true, then do display, and it sets the alpha. This draws the background box. Now it changes the color and changes the font alignment, and then sets the correct font and draws the text. And I even had some kind of bottom string there. I'm not quite sure what I used this for. This was hit E for next screen and so on, but this I ditched. And then it sets the alpha back to 1. There I glossed over this little thing here. If info equals 10, then player health packs equals 5. This is for the tutorial. This is another hard-coded value, because if info equals 10, this is this text box. To throw a bandage, hit string bandage key, and each time you collide with this sign where the index is 10, then you get 5 bandages. Again, this is only used here in the tutorial. So, but how do I choose which text box is being displayed here in the tutorial? And let's have a look at the tutorial room here. This is what the tutorial room looks like. You start here and then make your way across, and this is where Remy from down here gets attracted to you when you're probably in this vicinity here. And you can see I had to switch layers here, that I'm on my instances layer, where all my instances are. Pretty straightforward. And you can see here I'm starting, my player is here now behind this sign. So when I'm clicking onto this sign and doing a wonderful double click, and I probably have to zoom in here that we can see it, what's happening. There we go. Then there's a creation code. This is additional code that lets you run when this instance is being created. And most of the time I'm not using this creation code. And the reason for this is you easily forget it. When you're having a bug, you're not looking, most of the time you're not looking in the room editor where the code is that's conflicting with something. You go through all of your steps, you go through all of your objects here, go through all of your scripts, but something isn't right. And then probably you notice it after much too long that a certain object here has a creation code that messes things up. And like I said, I'm very likely to forget about this creation code feature, but I didn't find another way to easily implement this here. So you can see each of those signs here has a line of creation code, and it just reads info equals 1. And let's have a look at this. Creation code, now this was variables, creation code info equals 5, and this must be here the 10. Info equals 10. And this is which line of dialog of help gets selected. Let me close all windows. I'm already a bit confused there. Info box, there we are. And when it's being created, it has here info 0. So everything gets created with info 0, but then the creation code inside the room runs and overrides this info here. And this info is just here the index of the array containing all the strings here. I know maybe it would have been much better if I just had taken this string here and written it directly as the creation code there. But yeah, apparently I really love my arrays. Okay. And I've been streaming for the horrific amount of 3 hours and 27 minutes, Twitch keeps telling me. And apparently there's still 6 viewers there. And I would assume all of them comatose right now. And I'm absolutely sorry for boring you that much. But again, I thought it might have been interesting for anyone looking at my source code and wondering, WTF, what was he thinking? Why is this so convoluted? Well, now you know. Let me switch back. Oh, look at this. Still got some horrible drawings here open. So let's switch back to cam full. Hi, it is me in big, probably with a red nose tip. Oh my god, it looks terrible. It looks like I'm drunk or something. Again, yeah, thank you so much for watching for my first time Twitch only stream. If you're watching this on YouTube, you probably have at least a little bit of the chat in this box here if anyone's writing anything. Kirsty Boo is still there, gives me a thumbs up. Thank you so much for watching. And yeah, next week, my plans for next week are same time, same channel on Twitch, is to show you how to get cityscapes or pretty much any kind of terrain out of Google Maps and into Blender or your 3D application of choice. And this is not as straightforward as you would think. So yeah, I also found a nice tutorial on YouTube, and yeah, I had to learn some things about it the hard way. So I hope this is interesting, and then I will show you some progress on a little side project, a little pet project that I'm making. I've already tweeted about it, so if you follow me on Twitter, you already probably know what it is. But yeah, for this I need a background of a certain cityscape, and I needed to have a certain viewpoint, but didn't want to just take out screenshots from Google Maps because I want to do some different things with the lighting and so on. Point is, yeah, I thought I'd share what I found out and how to do this and how you can do it. Of course, you can't use Google Maps generated meshes and textures for commercial projects, or I don't think you can even use it for non-commercial projects because it's, well, the property of Google. But you can use those as references for proportions and pretty much anything along those lines, should you need it to, because this is what I'm looking to use it for. Again, thank you so much for watching. 9 viewers. Apparently I've gained some more in the past minutes, so I'm really sorry that you've missed absolutely nothing. And I hope to see you next week. And let me find the right slide there on OBS. Man, at least I was lucky to get out the ugly hum buzzing sound from the microphone from last time. So yeah, with each time I learned something new. Look at me, I'm a Twitch affiliate now. I have no idea what this entails, but hey, at least I got some forms concerning taxes filled out from me. So There we go. Again, have a great week. See you next weekend, and maybe I will do this streamy thing more often. I don't know when or how, but yeah, it's fun, and thank you so much for dropping by. Like I said, I don't take it for granted that people actually watch me talk into a camera in an empty room. This is so sad when I come to think about it. But anyway, let's not overthink it. Thank you so much for watching. See you next week, and have a great time until then. So long.